inspiration. Now I like to invite on mic Dr. Nitin Vilatkar sir, coordinator of today's seminar, for the introductory remark of this seminar.
Hello, hello. Good morning to all the respected person. Today's chairperson of today's program, Shri Badri Prasad ji Jaiswal, Vice President of Shri Durga Shikshan Samstha, Arjuni Morgaon. Respected Mukesh ji Jaiswal, Secretary of Shiv Prasad Sadananda Jaiswal, Shri Durga Shikshan Samstha. Respected Dhove sir, Department of Physics, RTVenu, Nagpur. Respected Professor Suresh Umre sir, Vice President of Nasi, Nagpur chapter. Respected Professor Ishwar Mahurle sir, Principal of Ssjc College, Arjuni Morgaon. Respected Professor Deshmukh sir, Principal of Rashtrapita Mahatma Gandhi College, Nagbir. Respected Professor Gurnule sir, Kamala Nehru Mahavidyalaya, Nagpur. Respected Professor Sanjeev Zhade sir, Department of Chemical Science, ISER, Kolkata. And the resource persons, faculty, respected professor, research scholar, and the student. I, Dr. Nitin Vilatkar, coordinator of this seminar, I welcome to you on the one-day national level seminar on recent trends in material science organized by Department of Chemistry and Physics, Shiv Prasad Sadananda Jaiswal College, Arjuni Morgaon, and Department of Chemistry and Physics, Rashtrapita Mahatma Gandhi College, Nagpur, in collaboration with National Academy of Sciences, India. We all are gathered here to explore the fascination, the world of material science, the field that can change our lifestyle, as when the first computer was made, its size is like that room, but the now computer is in our pocket, in the mobile or in the smartwatch. That all changes are due to the material. Material science is a main important factor of the today's modern innovation. The main aim to organize this seminar is to provide a platform to know the latest development in material science, such as design, synthesis, characterization, and its function of material, from sustainable energy solution to the synthesis novel biomaterial in the medical application. I am confident that at the end of this program, we will have gained a deeper understanding about the material science, its application, and its technology, and be inspired to contribute further for our society. Thank you.
Thank you, sir. Now, let us welcome the honorable dignitaries present on the dais. I would like to invite Dr. Sharad Deshmukh sir to welcome the chairperson of today's inaugural ceremony, our Vice President of Shri Durga Shikshan Samstha, Arjuni Morgaon, Honorable Shri Badri Prasad ji Jaiswal sir, with a floral bouquet. Thank you, sir. Now, I would like to invite Dr. Bhanse sir to welcome the Secretary of Shri Durga Shikshan Sanstha Arjuni Morgao, Honorable Shri Mukeshji Jaiswal sir with a flower bouquet. Thank you, sir. Now, I would like to invite Dr. Gopal Paliwal sir to welcome Professor Ishwar Morle sir, Principal of Shiv Prasad Sadanand Jaiswal College, Arjuni Morgao, by offering a floral bouquet. Thank you, sir. Now, I would like to invite Dr. Manoj Bangadkar sir to welcome respected Professor Deshmukh sir, Principal of Rashtrapita Mahatma Gandhi Arts and Science College, Nagbid, by offering a floral bouquet. Thank you, sir. Atithi Devo Bhav. Under this theme, we also have some of our guests and we welcome them, also we felicitate them. So for that, I humbly request Shri Badri Prasadji Jaiswal sir, President of today's program, to welcome and felicitate Professor Vasudev Gurnure sir from Kamla Nehru College, Nagpur, by offering him a shawl, floral bouquet. Thank you, sir. We are delighted to have with us some of the most eminent minds in the field of material sciences, that is our resource person of the technical session. To honor their esteemed presence, we would like to welcome and felicitate them. To felicitate our first resource person, Dr. Sanjay Dobde sir, Department of Physics, RTM Nagpur University, Nagpur, I would like to request Honorable Shri Badri Prasadji Jaiswal sir to felicitate and welcome Dr. Dobde sir by offering him a shawl, floral bouquet and memento. Memento. Thank you, sir. Our next resource person is Professor Sanjeev Zade sir from Department of Chemical Sciences, ISER, Kolkata. I humbly request our Secretary Shri Mukeshji Jaiswal sir to welcome and felicitate Professor Zade sir by offering him a flower bouquet, shawl and memento. Thank you, sir. Our next resource person is Professor Suresh Umre sir from Department of Chemistry, VNIT, Nagpur. I again humbly request Shri Mukeshji Jaiswal sir to felicitate and welcome Professor Suresh Umre sir by offering a bouquet memento. Thank you, sir. Now I would like to invite Pankaj Oke sir to welcome the coordinator of today's seminar, Dr. Nitin Vilatkar sir, by offering a floral bouquet. Thank you. Thank you, sir. To formally commence this prestigious seminar, we begin with the welcome address. It is our privilege to have with us Professor Ishwar Maurle, sir, the esteemed principal of our institution, whose visionary leadership and unwavering support have been instrumental in organizing this event. With great honor and respect, I now invite Professor Ishwar Maurle, sir, to deliver welcome address.
Thank you, sir. Good morning, one and all. On behalf of the organizing committee, it is with great pleasure that I welcome you all to this national level seminar on recent trends in material science. I heartily pay my tribute to Rashtra Sant Tukadoji Maharaj and Shraddheya Shiva Prasad Ji Jaiswal, who is founder of the trust Shri Durga Shikshan Sanstha. In this seminar inaugural function, the inaugurator, Honorable Vice Chancellor of Gondwana University, Gadchiroli, and Rashtra Sant Tukadoji Maharaj, Nagpur University, Nagpur, Honorable Dr. Prashant Bukare, sir. Though he is not present here due to his emergency at Mantralaya, but sir has sent the message for all of us. The chairman of this function and vice president of the trust, Shri Durga Shikshan Sanstha, Honorable Shri Badri Prasad Ji Jaiswal. Another dignitary on the dais, our secretary of the trust, Honorable Shri Mukesh Kumar Ji Jaiswal. In this seminar, the technical sessions will start after the end of this inaugural ceremony. And on the dais, the chief guest, my friend Dr. Sanjay Dhobane, who is the renowned physicist in the world. As per the data, in the world, it is amongst 0.5% of the physicists. And I think since 22, 24, he is amongst the 2% of the physicists in India and in the world also. So such a great personality is amongst with us in the today's seminar. Another chief guest, another chemist, I can say, my friend Professor Dr. Vasudev Gurnule. He is also renowned chemist in India as far as the chemistry is concerned. This national level seminar is a joint venture which is hosted by our college in collaboration with Rashtrapita Mahatma Gandhi College Nagpur and Nasi Nagpur. All the delegates, teaching and non-teaching faculties from our college, and dear participant students, we are truly honored to have such a distinguished gathering of experts ready to deliver into critical discussions and share valuable insights on this vital subject, material science. Let us make most of these opportunities to learn, to network, and collectively contribute to advancing knowledge in the field of material science. I am honored to be your host for this significant event. Before we begin, I would like to extend a warm welcome and heartfelt thanks to our speakers, Professor Ssjc sir, Senior Professor Dhobde sir, and Professor Umre sir, who are present over here, our sponsors, all those individuals, the trust which sponsors finances to this seminar, all the attendees who have taken the time to join us today. For presence and participations are what make this seminar meaningful and impactful. Ssjc College, runs by Sri Durga Shikshan Sanstha ARJUNI Morgaon since 1990. The college has organized many such events in this rural, tribal and Naxal region, which is near about 150 kilometers from Nagpur and Chandrapur, 80 to 90 kilometers from Gondia, Gadchiroli. So it is just the inner region, but only because of the love on us, on our institution, on our management, most of the participants are registered for this one-day national seminar. Near about 135 plus faculties are registered. Near about 150 plus scholars and PG students are registered, and some of the undergraduate students who are interested, and they registered to attend this one-day national seminar. So I congratulate all of them. So here, this event serves as a platform for sharing knowledge, discussing innovative ideas, fostering collaborations. So we aim to learn, inspire, innovate, and hope that each of you will find this experience enriching and beneficial. I extremely congratulate to our coordinator, Dr. Vilaytkar and Dr. Chaudhary, and his organizing team. I want to welcome you all and thanks you once again for being here. So your presence and participations are what make this seminar a success. Thank you and enjoy the seminar. Thank you once again.
Thank you, sir. Now, with great honor and respect, I would like to invite Professor Vasudev Gurnule sir from Kamla Nehru College, Nagpur, to share his thought with us.
Good morning to all of you. The dignitaries on the dais, the society management members, vice president sir, secretary, and inaugurator, Professor Dhobde sir, Professor Umre sir, and all the dignitaries on the dais, any of the dais. today we have gathered here for this inauguration. As we know that this is the interior place, and the hall is full. So this is the grand success of this national conference, first thing. Second thing is that here I observed, here the theme of the conference selected is very, that is advantageable to all of us, and what is the recent trends in the material. So this is also another thing that everyone can participate in this seminar, and just Professor, that is Sir, the principal sir told just now, more than 150 participants have registered for this. So this is another thing that is the grand success of this national conference, because this is the interior place, so much far away from the national highway and from the cities. So congratulations, sir, for this grand success of this national conference. And I can also say that eminent speakers are here to learn from them. So Professor Dobre sir, one of the speakers, Professor Umbre from VNIT, and Professor Jhade sir from the IJAP, Kolkata. So we can learn something from them, and also all the audience can get benefit of this. As we know, today we are living in a dynamic world, and as we know that the basic, that is the backbone for sustainable development is the science and technology. As we know that science and technology are different, but at the same time they are complementary with each other. As we know, what is science? Science is the pursuit of knowledge, and technology is the creation of artifacts for the people needs. So science and technology makes the life comfortable, make many things. So we can say that this modern scenario, or this modern age of science is the basic, that is the basic science is the science and technology. This science and technology, our basic needs are depends on that, and any country, development of any country depends on this science and technology, and therefore, this technology based on the materials. So many research is going on in the materials, and in future also, so many different types of materials will come, and day by day, there are so many changes in the advancement of the technology, and therefore we are using all this technology for our progress, for the society, and for the mankind. And as we know that nanomaterial is the recent, that is the developed material. In case of nanomaterial, in advancement of nanomaterial, the complete world going to change and show so many changes in the world. So I am not taking more time. So we have to learn from the speakers today. So instead of taking more time, here at the end I say that I congratulate all the organizers for the nice arrangement and for organizing such a national level seminar for the student and for also faculty members. So I congratulate on this occasion for the success of this national conference. Thank you.
Thank you, sir. Now, with great honor and respect, I would like to invite Professor Suresh Umbre, sir, from VNIT Nagpur to share his views on this occasion.
Friends, good morning, one and all. Shri B.R. Jaiswal ji, the Vice President of this society. Dr. G.N. Deshmukh, the Principal of RNG College, Nagbhid. Professor Moharle, Principal of this college. The speakers, Dr. Dobre, Dr. Jhade, Dr. Gurnole, the participants, and dear friends, good morning, one and all. So, I will brief about the Nasi. We know everyone. Nasi, it is a National Academy of Sciences, India. It is formed in 1930. It is one of the oldest science academy of India. There are two more academies, INSA, New Delhi, the Indian National Academy of Sciences, New Delhi, and other one is a Science Academy of Indian Science Academy, Bangalore. So these academies, they form latter. Professor Meghnad Shah, he was the founder president of Nasi, and he was one of the greatest astrophysicists, and he's among the scientists like the Professor C.V. Raman, Sri Chandrasekhar, Ramanujan, the great scientist, and he has discovered, basically proposed the ionization theory. That ionization theory which is used for the calculation of the physical and chemical properties of the different stars. And this is one of the greatest invention amongst the 10 inventions after the discovery of telescope. We know telescope that was discovered by the Galileo. So this is one of the greatest discovery by Professor Meghnad Shah. Professor Meghnad Shah, he was nominated for again a Nobel Prize in 1934, 35 and 36. And he has established the Nuclear Science Institution in India, and his name, it is proposed after his death. Now it is the Meghnad Shah Institute of Nuclear Sciences. It is in Kolkata. So the president, we have a Nasi chapters all over the country. We have around 22 Nasi chapters all over the country. And Nagpur, we have a chapter, and Professor N.S. Gajbee, he was the president of the Nasi Nagpur chapter. Because of some reason, he unable to come. So I'll be presenting his message. Professor N.S. Gajbee, he is the ex-professor of IIT Kanpur, is former vice chancellor of Upadhyay Gorakh University, Gorakhpur, as well as Dr. Hari Singh Gaur Central University, Nagpur, and he is the chairman of the National Academy of Sciences, Nagpur chapter. So it is my honor to present his message. I quote, "It gives me immense pleasure to extend my heartiest greetings and best wishes to all the organizers, dignitaries and participants attending the National Conference on Recent Trend in Material Science for Sustainable Development, organized by Department of Chemistry and Physics, Shri Prasad Sadananda Jaiswal College, ARJUNI, Morgaon, on 3rd February 25. The theme of this seminar holds immense significance in today's world, where the need for sustainable development is more pressing for materials used for advanced technology than ever. Material science play a vital role in addressing the global challenge from renewable energy solution to eco-friendly innovations. Events like this provides a vital platform for researchers, academicians, and industry experts to share the ideas, foster collaboration, and inspire innovative solutions. I commend the organizing committee for their efforts in bringing together such distinguished groups of experts and students. Your dedication to promoting knowledge and innovation is truly commendable. Once again, I congratulate the organizers and extend my best wishes for the success of this conference." I unquote. So thank you for listening. Thank you very much.
Thank you, sir. And on behalf of our institute, I thank Professor G.N. Gajbee, sir, for his message to our institute and for this national seminar. Now it's time to release our souvenir. I request all the honorable dignitaries present on the dais to release the souvenir of today's national seminar on recent trends in material sciences for sustainable development. Sir. Thank you so much. Now, with great honor and respect, I would like to invite on mic Senior Professor Dr. Sanjay Dhobde sir from Department of Physics, RTM Nagpur University, Nagpur, to share his thoughts with us.
Good morning to all. Honorable Chairman of this conference program, Jaiswal sir, Secretary of this college, Jaiswal sir, Principal of this both college, and all experts, my friends and dear students. सभी ने आपको तो बहुत इंग्लिश में डोज पिला दिया है, मैं आपके दिल की लैंग्वेज में बात करूंगा। पहली बात तो ये हॉल भर गया है, पता है ये पहला कॉन्फ्रेंस का सक्सेस। हॉल क्यों भरा, ये दूसरा क्वेश्चन है। आपको मालूम है इस कॉलेज के प्राचार्य नहीं है, नाटककार है। मोरले सर बराबर है, हाँ, वो झाड़ी पट्टी के एक्सपर्ट नाटककार है, इसलिए हॉल कैसा भरना ये उनको बहुत अच्छे से पता है। और मैं इसलिए आया क्योंकि कोई भी भगवान बुला ले तो किसी को भी कभी भी जाना पड़ता है। मुझे भी यहाँ भगवान ने बुलाया क्योंकि ईश्वर ने बुलाया, तो उनको आना ही था। और जब ईश्वर बुलाएगा तो कौन नहीं जाएगा, तो हम आए हैं। लेकिन मैं चाहता हूँ कि यहाँ एसएस कॉलेज, जायसवाल कॉलेज है, इसका नाम अंतर्राष्ट्रीय स्तर पे बढ़ता रहे। यहाँ के स्टूडेंट और आए हुए सभी पार्टिसिपेंट अच्छा प्रोग्रेस करते रहे, क्योंकि यहाँ पे हमारे बहुत से बड़े दोस्त आए हैं जो बोर्ड ऑफ स्टडीज़ के मेंबर है, मेरे आंखों के सामने दिख रहे हैं, तो आए हुए तो बहुत अच्छा लग रहा है। ये एक प्रिंसिपल का उनके फैकल्टी और अदर फैकल्टी के साथ जो रिलेशन होता है उसको इंडिकेट करता है। ये सही में बहुत अच्छी बात होती है, इस कारण ये यहाँ पे मैक्सिमम पार्टिसिपेंट आए हैं। लेकिन इस कॉन्फ्रेंस के बाद आप जब जाओगे तब आपके पास क्या लेके जाना है, इसके लिए आपको कुछ विचार करना पड़ेगा। आज की डेट में जॉब बहुत कम है, नहीं के बराबर माना तो भी चलेगा। आपको जाना है तो आप रिसर्च बेस पे अच्छे तरह जा सकते हैं, और रिसर्च बेस पे अच्छा काम करके आपको बहुत कुछ मिल सकता है। आपको पता है कि एमएससी के बाद जब आप पीएचडी करते हो तो पीएचडी में अच्छी अच्छी फेलोशिप्स है। राजीव गांधी फेलोशिप है, महात्मा ज्योतिबा फुले फेलोशिप है, बाटी की फेलोशिप है, बहुत सारी फेलोशिप है। जो यूनिवर्सिटी टॉप करके आता है उसको डीएसटी की फेलोशिप है, और वो भी फेलोशिप इतनी छोटी सी नहीं है, 37,000 प्लस HRN 42,000 फेलोशिप मिलती है। तो आप पीएचडी एमएससी के बाद पीएचडी करके आप अच्छा काम कर सकते हैं। और एमएससी और पीएचडी में आपने ध्यान लगा के पढ़ा और पीएचडी में अच्छे पेपर पब्लिश किए, स्कोपस में पब्लिश किए, तो आपको पोस्ट डॉक फेलोशिप आराम से मिलती है। जो बाहर में देश में है वो कम से कम 2 से 3 लाख रुपये पर मंथ रहती है। मैं इसलिए दावे के साथ कह रहा हूँ कि अभी तक मैंने 16 स्टूडेंट मेरे स्टूडेंट को पोस्ट डॉक के लिए भेज चुका हूँ, और उन स्टूडेंट के मिनिमम 15 के ऊपर ही स्कोपस में पेपर पब्लिश किया विद इन द 3 ईयर। ये मेरी लिमिट होती है। हम रात दिन काम करते हैं, जो सब्जेक्ट में काम करते हैं उसको हम अच्छे से करते हैं। और मैं अकेला फिजिक्स पे काम नहीं करता, मुझे फिजिक्स में काम करना तो मेरा बेसिक है, जहाँ से मेरे को रिसर्च मेथोडोलॉजी मिली हुई है। आई विल ट्राई टू वर्क इन द डिफरेंट सब्जेक्ट, इट इज कॉल्ड मल्टी डिसिप्लिनरी वर्क। हमारे नागपुर शहर में या अपने विदर्भ में ऐसे एक नेता है जिन्होंने हमें एक नया मंत्र दिया हुआ है। एक मंत्र उसका भी है, चहापेक्षा काटली गरम, त्याच्याशी मला काही बोलायचं नाही, ते राजकारणी सेंटेंस है। लेकिन नितिन जी गडकरी ने एक सेंटेंस अच्छा बोला है, मैं उनको सिग्नेचर मानता हूँ, उनका मैथमेटिकल सिग्नेचर ऑफ नितिन जी गडकरी साहब, a+b² = a² + b² + 2ab। ये आपने सभी ने पढ़ा, आपको सब अच्छे से पता है। उनका कहना है कि a और b 2 पर्सन है, a² b और b² काम करेंगे, लेकिन जब a और b दोनों मिलकर काम करेंगे a और +b² तो a² b + b² + 2ab होता है। ये 2ab यानी आपका ज्यादा से ज्यादा काम होता है। उसको मल्टीडिसिप्लिन वर्क और आप अपनी रेंज बढ़ा सकते हैं। इसलिए जहां भी आप साथ में काम करोगे बहुत अच्छा रहेगा। मैं इस कॉलेज में शायद तीसरी बार आया हूँ सर। एक बार आया था, मेरे को बहुत से जगह कुछ चुराने की आदत है, मैं एकेडमिकली महाचोर हूँ। मैं यहाँ पे आया, मैं एक कमेटी में, तो मुझे यहाँ के माइक्रोबायोलॉजी के सर है डॉक्टर शरद देशमुख सर, उन्होंने बड़े उत्साह के साथ बताया एक प्लांट है, एक फ्लोटिंग प्लांट है, ये ऑक्सीजन इमिट करता है। मतलब बहुत अच्छी बात है, लेकिन एब्जॉर्ब क्या करता है? बोले कार्बन डाइऑक्साइड एब्जॉर्ब करता है। फिर मैंने सोचा कि कार्बन डाइऑक्साइड एब्जॉर्ब करके क्या होता है, ऑक्सीजन होता है, वो मॉस्किटोज को रिपेलेंट के लिए बहुत अच्छा काम करता है। उसके बाद हमने देशमुख सर के साथ में नागपुर यूनिवर्सिटी में एक प्रोजेक्ट सबमिट किया और इस कॉलेज को मिला वो पहला प्रोजेक्ट था। हम एक बार भी जहां कदम रखे उस कॉलेज को हम आगे बढ़ा के ले जाते हैं। इतना ही नहीं, मैं देशमुख सर के साथ इंडोर प्यूरिफिकेशन, आउटडोर एयर प्यूरिफिकेशन पे 2 इंटरनेशनल पेटेंट बनाए और इस कॉलेज का नाम देशमुख सर के साथ मैंने इंटरनेशनल लेवल पे ले गया। इस कारण मैं मानता हूँ कि मैं इस कॉलेज का फैमिली मेंबर हूँ। भले मोहरे सर माने ना माने, मैं मान जाता हूँ। जबरदस्ती करने में क्या हरकत होता है? अपना ही दोस्त है यार, वो ईश्वर है, ईश्वर के सामने रिक्वेस्ट करना अपनी आदत होती है, कोई बुरा नहीं है सर। और उसके बाद इस कॉलेज में 2 और प्रोजेक्ट आया, एक फिजिक्स में सर को आया और एक प्रोजेक्ट आया। तो एक बार कोई चीज किसी कॉलेज के लिए हो जाती है तो उसके लिए नॉर्मल चीज होती है और एक एक बार सब आते रहता है। इसलिए हम सभी का दायित्व बनता है हम अपने साथ में दूसरे सब्जेक्ट में अच्छा काम कर सके, तब जाके अच्छा काम होता है। नहीं तो आप फिजिक्स में करें, मैं एलईडी मटेरियल पे काम करता हूँ, बहुत से काम किए हैं, टीएलडी मटेरियल पे काम करता हूँ, सोलर सेल मटेरियल पे काम करता हूँ, उसके साथ में बहुत से सब्जेक्ट में काम करता हूँ। वो मेरे टॉक में दिखेगा। मेरा टॉपिक ही है मल्टीडिसिप्लिनरी रिसर्च, और यही आज की डेट की टेक्नोलॉजी है। जो टेक्नोलॉजी है उसमें अगर आप काम करोगे तो बहुत अच्छा कर पाओगे। अभी कुछ दिन पहले आपने थोड़ा सा सुना होगा कि मैंने फोल्डिंग हेलमेट बनाया। अच्छा, आपने पेपर में भी सुना होगा उसके बारे में, टीवी न्यूज पे भी आया था। जब मैं फिजिक्स के बाहर काम करता हूं तो मेरे को टीवी वाले कवर करते हैं, फिजिक्स में काम करता हूं तो वो टीवी वाला आता नहीं। ये सबसे बड़ी दुख की बात होती है। इसलिए मेरी आदत हो गई सोसाइटी के लिए कुछ तो भी करो। रिसर्च 2 टाइप का होता है, एक सोसाइटी के लिए करो और दूसरा एकेडमिकली स्ट्रांगली करो। तो मैं एकेडमिकली स्ट्रांगली तो रिसर्च करता हूँ, इसलिए मेरे 2 पेपर 48 इम्पैक्ट फैक्टर में भी है और मैंने अभी तक के 78 पीएचडी स्टूडेंट अवार्ड कर चुका हूँ। बोला जाता है कि किसी की पीएचडी स्टूडेंट और उसकी उम्र में ज़्यादा फर्क नहीं होना चाहिए। मैं मान के चलता हूँ कि मैं 78 के ऊपर जिंदा रहूंगा, इसलिए 78 स्टूडेंट पीएचडी हो चुके हैं। मानने में क्या हरकत होता है? हम फिजिक्स वाले सपोज जो बड़ा कोई इक्वेशन में ऐसा टारगेट आता है उसको ब्रैकेट में डालते हैं और उसको सपोज करके कांस्टेंट सी करके लिख देते हैं। वैल्यू निकालना है निकालो, जो कंडीशन लगाना है लगा लो, तो अलग की बात होता है। एक मैथमेटिकल कैलकुलेशन का एक रूल्स है, इसलिए मैथमेटिक्स से काम करना भी बहुत अच्छी बात होती है। मैंने मशीन लर्निंग में कंप्यूटर साइंस के साथ में प्रेडिक्शन किया हुआ है, उसमें भी अच्छा रिसर्च चल रहा है। और काम करते समय हम अपने कॉलेज का नाम अच्छा करना चाहिए। हमने आपको बताया कि हम जिस कॉलेज में रहते हैं, जिस यूनिवर्सिटी में काम रहते हैं, उससे बारे में पेपर में हमेशा नेगेटिव न्यूज़ आती है, तो गलत बात होती है। हमें हमारे कॉलेज के बारे में, हमारे इंस्टीट्यूट के बारे में, हमारी यूनिवर्सिटी के बारे में पॉजिटिव न्यूज़ आना चाहिए। इसलिए मैं 7 साल एक कॉलेज का प्राचार्य था, तो जो छोटी छोटी अच्छी चीज़ें होती थी, जो लोगों को प्रेरित करती थी, वो हमेशा पेपर में देता था। इस कारण कॉलेज के एडमिशन बढ़ते हैं। कॉलेज के एडमिशन के लिए बैनर लगाने की जरूरत नहीं होना चाहिए। आपके न्यूज़पेपर में जो लोगों तक पहुंचता है वो बात आते रही तो कॉलेज के अच्छी बात होती है। और जल्दी ही हम और इस कॉलेज के साथ तीसरा भी पेटेंट निकालने जा रहे हैं, और जो पेटेंट मिलेगा तो इस कॉलेज में बहुत अच्छा महसूस होगा। मैं चाहता हूँ देशमुख सर और अच्छे से काम करें, और मेरे साथ में जो अलग अलग सब्जेक्ट के लोग काम करते हैं उसमें सब अच्छा मिले। मेरे टॉक में अलग अलग सब्जेक्ट के साथ में अच्छा वर्क दिखाया गया है, जिसको जो भी पसंद आए वो कर सकते हैं। और मैं किसी के साथ भी काम करता हूँ, कोई भी सब्जेक्ट के साथ काम करता हूँ, तो एक कंडीशन है, वो हार्ड वर्किंग होना चाहिए। हार्ड वर्किंग अगर रहा तो बहुत अच्छा होता है, और मैं बहुत अच्छे से उस सब्जेक्ट को निभाता हूँ। मैं अभी बहुत वैसे भी हम लेट हो गए थोड़ा सा, क्योंकि यहाँ पे दूर दराज के लोग आते हैं और हमको और इससे ज़्यादा टॉक में बोलना है, तो मैं ज़्यादा नहीं बोलूँगा। तो ईश्वर सर को इतना ही शुक्रिया करूँगा, सर आपने ज़मीन पे बुलाया अच्छा लगा, ऊपर मत बुलाना। तो ईश्वर की भरोसा नहीं है सर। अच्छा नहीं, साथ में नहीं, आपको जल्द। तो मैं ज़्यादा नहीं बोलूँगा, आपने बुलाया इसलिए बहुत बहुत शुक्रिया। और जायसवाल सर, आपका कॉलेज बहुत आगे बढ़ रहा है। आप अपने प्राध्यापकों पे, अपने प्रिंसिपल पे विश्वास रखो कि वो फिजिक्स वाला है, फिजिक्स वाले कमजोर नहीं होते। सॉरी, केमिस्ट्री वाले भी बैठे हैं यहाँ पे। बुरा लगे तो कोई हर्क नहीं होता, अपन अपनी तारीफ करना चाहिए। मोदी जी करते हैं ना, वो बोलते कि अपने पक्ष का काम हर घर में पहुंचाओ। हम भी पहुंचाते हमारे फिजिक्स का काम, हमारा रिसर्च हर घर में पहुंचना चाहिए, तभी ये बच्चों को जॉब मिलेगा सर। ये जॉब नहीं मिले। मेरे स्टूडेंट को मैं बोलता हूँ रिसर्च के अंदर, जब तक आप 10 से 15 पेपर पब्लिश नहीं करेंगे आपको प्राइवेट यूनिवर्सिटी में जॉब नहीं मिलेगा। प्राइवेट यूनिवर्सिटी में जॉब चाहिए तो 10 से 15 इंटरनेशनली स्कोपस पे पेपर पब्लिश करना पड़ेगा, क्योंकि उसकी उनको जरूरत है। और आराम से 85,000 के ऊपर पगार दे रहे हैं आजकल। मेरे 2-3 स्टूडेंट हैं जो प्राइवेट यूनिवर्सिटी में पढ़ रहे हैं, 85 के ऊपर पेमेंट है। और गवर्नमेंट एडेड कॉलेज में जाना है तो मेरे को कितना फिगर लगता है। यहाँ सर बैठे हुए उनको पता है, मैं नहीं बोलूँगा सबके सामने क्योंकि स्टूडेंट है। इसलिए आपको अपने माँ बाप की ज़मीन बचाना है, माँ का मंगलसूत्र बचाना है, तो आपको बहुत मेहनत करके अच्छे पेपर करना पड़ेगा। और आपको पोस्ट डॉक के लिए भेजना है तो मेरे पास आइए, कोई भी सब्जेक्ट में पोस्ट डॉक में भेजूंगा। आपको प्राइवेट यूनिवर्सिटी में जॉब चाहिए, 15 पेपर पब्लिश कीजिए, मैं जॉब आपको दूंगा। जॉब की आपके लिए कमी नहीं है, केवल आपको इंटरडिसिप्लिनरी वर्क करना पड़ेगा। और मैं जैसे 18 घंटे काम करता हूँ रोज, आपको भी करना पड़ेगा, तो आप एक दिन अच्छे से बन जाओगे और जिस शहर या गांव से आए हैं उसमें अच्छा श्रेय करोगे। और मैं मानता हूँ, लास्ट में एक ही बात बोलूँगा, गांव के लोग बहुत होशियार, मेहनती और ईमानदार होते हैं। और मेरे 78 में मैक्सिमम 70 स्टूडेंट वही है। इसका मतलब शहर के लड़के वो होशियार नहीं होते, ऐसा नहीं, वो अपने से भी स्मार्ट रहते हैं। हमको जो बैकग्राउंड मिला हुआ, जो फैसिलिटी मिला, इसका हम थोड़ा पीछे रहते हैं, लेकिन अपन मेहनत करके उसको पूरा करने की कोशिश करते हैं और ईमानदारी के साथ आगे बढ़ते हैं। और उसी का एक उदाहरण मैं आपके सामने हूँ। धन्यवाद। ईश्वर सर ने बुलाया, जमीन पे बुलाया, इसलिए उनकी बहुत बहुत शुक्रिया अदा करता हूँ। सर आप ऐसे बुलाते हैं, हम आते रहेंगे। थैंक यू।
Thank you so much, sir. Now, I would like to invite on mic Professor G.M. Deshmukh, sir, Principal of Rashtrapita Mahatma Gandhi Arts and Science College, Nagpur, to share his thoughts with us.
At the outset, I pay my tribute to the memory of Rashtrasanta Tukaji Maharaj, Founder President, late Shiv Prasad Ji Jaiswal, dignitaries on the dais, Chairperson of this inaugural session, Vice President Badri Prasad Ji Jaiswal, Honorable Secretary Mukesh Ji Jaiswal, organizer of this wonderful national level seminar, my teacher Dr. Ssjc Morle sir, resource person Honorable Professor Sanjeev Jhade sir, Honorable Professor Sanjay Dobde sir, Honorable Professor Suresh Umre sir, dignitaries on the dais and off the dais, and galaxy of intellectuals present here to deliberate upon the recent trends in the material science. As already said, Dobde sir, the students from the rural area have the ability to excel in their future, but they do not have the exposure, proper exposure. And organization of such kind of national level seminar have got the proper platform to have the deliberation, to have the to share the platform with the resource persons like the Jhade sir, Dobde sir and Umre sir. And the whatever the technical session, three technical sessions have been arranged here, and we have got a lot of exposure, and that definitely ignite the minds of young scientists present here, and that will go a long way in their shaping their future. Already we are running late. I will not take much time, and I wish all the success for the organizers, and whatever the under the able leadership of Dr. Morle sir, they have done here wonderful, and it is shown by the such a huge gathering present over here. So I wish all the success. I conclude here. Thank you.
Thank you, sir. Now it is the time for the much awaited inaugural address. As our principal Ishwar Mohorle sir has already told that Vice Chancellors of Gondwana University Gadchiroli and RTM Nagpur University Nagpur Dr. Prashant Bokare sir was unable to share dais with us today, but he has sent a video clip of inaugural message. So I request the technical team to play the video clip of inaugural address.
नमस्कार. ही जी कॉन्फरन्स महाविद्यालय घेत आहे, या कॉन्फरन्ससाठी मी महाविद्यालयाचे प्राचार्य, या महाविद्यालयाचे शिक्षक आणि शिक्षकेतर कर्मचारी आणि विद्यार्थी यांचं हार्दिक अभिनंदन करतो. या कॉन्फरन्समधनं केवळ विदर्भातील शिक्षण क्षेत्रालाच नव्हे तर राज्यभरातील शिक्षण क्षेत्राला एक नवीन शैक्षणिक मेसेज आपण देऊ शकू असा मला विश्वास आहे. हे कॉन्फरन्स आयोजन करण्यामध्ये काय कष्ट असतात याची मला कल्पना आहे. त्यामुळे प्राचार्यांचं आणि या कॉन्फरन्सला प्रेरणा देणाऱ्या डॉक्टर डांगेंचं मी विशेषत्वानं अभिनंदन करतो. या कॉन्फरन्सला माझ्या हार्दिक शुभेच्छा.
Thank you, sir. Thank you so much. Dear friends, we are privileged to have with us the chairperson of today's program, Shri Badri Prasad Ji Jaiswal sir, Vice President of Shri Durga Shikshan Sanstha Arjuni Morgaon. Our Vice President has always been a source of inspiration and guidance. He always support initiatives that support academic excellence and research. With great respect and admiration, I now invite Shri Badri Prasad Ji Jaiswal sir to encourage us and give a presidential remark.
परम पूज्य राष्ट्र संत आदरणीय राष्ट्रसंत टुकड़ोजी महाराज, हमारे स्वर्गीय भाई शिव प्रसाद जी जायसवाल, इन दोनों की प्रतिमा को सादर प्रणाम करते हुए आज का जो कार्यक्रम आयोजित किया गया है, साइंस के प्रति जो देश में इसका जो लाभ मिलना चाहिए, हमारे विद्यार्थियों के माध्यम से, हमारे कॉलेज के माध्यम से आए हुए मंच पर विराजमान प्रमुख अतिथि श्री डोबड़े जी तथा अन्य आमंत्रित निमंत्रित मेहमान, मेरे कॉलेज के प्राध्यापक वर्ग, विद्यार्थियों, कॉलेज के प्रिंसिपल श्री मोहरले, संस्था के सेक्रेटरी श्री मुकेश जायसवाल, आज इस कार्यक्रम के निमित्त आप लोगों ने जो कुछ भी अपना मार्गदर्शन भविष्य के प्रति और साइंस के माध्यम से जो मिलना है, इसके लिए आज के इस कार्यक्रम के अंतर्गत प्रमुख रूप से आदरणीय डोबड़े जी ने जो आप लोगों को सलाह दी है, सलाह ये है मेहनत और ईमानदारी से यदि काम किया जाए, सफलता की कुंजी मेहनत है और मेहनत ईमानदारी से किया जाए तो हर क्षेत्र में अच्छी ढंग से आगे बढ़ सकते हैं। आज विद्यार्थी वर्ग के प्रति जो उनकी भावना है भविष्य के प्रति कोऑपरेट करने की, ये सराहनीय है। ऐसी अपेक्षा रखते हुए सभी यहाँ आए मेहमानों से मैं आशा रखता हूँ वो भी हमारे कॉलेज के विद्यार्थी को, प्राध्यापकों को और हमारे संस्था को जो कुछ मार्गदर्शन करेंगे, निश्चित रूप से यह संस्था आगे बढ़ेगी, हमारा कॉलेज बढ़ेगा। इसके लिए मैं उन सभी को धन्यवाद देता हूँ और आए मेहमानों के प्रति एक आभार व्यक्त किए अपने वाणी को विश्राम देता हूँ। धन्यवाद।
Thank you, sir. Now to propose vote of thanks, I invite Dr. Dwalpa Chaudhary, sir, co-coordinator of today's national seminar.
Thank you, sir. First of all, I tribute to Rashtrasanta Tukadoji Maharaj, late Sri Sivrasji Jaiswal, honorable guest on the dais, dignitaries, delegates from the different colleges, research scholars, and my dear students. First of all, I am thankful to management of our institute, management body of the Durga section Sanstha ARJUNI more. They always encourage us to organize these such type of programs. I am thankful to the chairman, program chairman, Sri Baddi Prasadji Jaiswal, Vice President of the Durga Education Society, to present and address on this occasion. I am thankful to Jaiswal sir. I am thankful to the Secretary Mukesh ji Jaiswal sir for their gracious presence. I am thankful to the distinguished speakers they present here on this occasion. Senior Professor Honorable Dhobde sir, they present here and they guide us on this occasion. Jhade sir from the ISER Kolkata. I am thankful to the Umbre sir on this occasion. I am thankful to all the dignitaries they present here in this inaugural ceremony, all the delegates from the different institutes, also the research scholar and MSc students and UG students of our college. I am thankful to the one and all who present here on this occasion. Thank you. From the kind permission of the today's chairman here, I declare that this inaugural session is ended here. Thank you.
Thank you, sir. Now in few minutes we will start with our first technical section. For technical session, I would like to request Nilesh Gode sir, Head of Department of Chemistry, RMG College, Nagpur, to proceed the event.
नाही इथं ठेवता का?
ठीक आहे जमलं. हॅलो 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 हां चालू करा. बुके बुके द्यासाठी हॅलो हॅलो हॅलो. Good morning, ladies and gentlemen, esteemed guests and conference participants. Welcome to one-day national seminar on recent trend in material sciences for sustainable development. Myself, Assistant Professor Mr. Nilesh Gode, host of today's technical session 1. We are gathered here to exchange ideas and open discussion on recent trend in material sciences. It is indeed a golden opportunity for each of us to enrich and enlighten ourselves. Without further taking time, let's dive into our promising schedule. I kindly request Chairman of Technical Session, Professor Hemant Chandak Sir, BOS, Amravati University, and Speaker of the Technical Session, Honorable Dr. Sanjeev Jhade Sir, Department of Chemical Sciences, ISER, Kolkata, to take their seats on dais. Thank you, sir. Now I request Dr. Atul Nagpure sir to welcome Chairperson of today's session, Professor Hemant Chandak sir, by offering a flower. Thank you, sir. Thank you. Now I request Dr. Vikas Mohature sir to welcome Professor Ssjc, sir. Thank you, sir. We are fortunate to have eminent personality in chemical sciences, Honorable Professor Ssjc, sir, ISER, Kolkata. He did his BSc, MSc from Amravati University, Amravati. He did his PhD at IIT Mumbai 2004. He held various positions, currently working as a professor in ISER, Kolkata. He had a research area like conjugated polymer, semiconductor device, molecular designing, solar scale application, optic, electronical appliances, and many more. He has published various research articles in renowned international publication houses, American Chemical Society, Royal Society of Chemistry, Wiley Publication, elsewhere, etc. He has 5,000 citations on Google Scholar, more than 5,000 citations in Google Scholar. Also more than 130 publications in Scopus, having H index 32. He is the editor of many renowned international journals. He has attended many national, international conferences and seminars. List is too long, but I will not take much more time, and we start our technical session. So I kindly request Honorable Professor Ssjc, sir, to please start.
Thank you very much for kind introduction, and I thanks chair of this session, Professor Chandak, and I also would like to thanks my friend Nitin Vilaytkar, who made it happen to come once again here. I was here in the same college, same place. We have given the lecture along with Professor Chandak for the BSc student, and we also showed some experiment, magical chemistry experiment to them. Okay, so let's start this presentation. Okay, so it's about the flexible molecular electronics, and from the perspective of molecular structures. So you can see from the title, I have mentioned molecular structure, and molecular structure we can create by using synthetic chemistry. So from title you can understand I am mainly the synthetic organic chemist who basically make the molecule for specific purpose, and our purpose is to make the organic semiconductor. When you make the conjugated molecule, for example, if you have the simple ethylene molecule, and if you connect ethylene molecule by simple single bond, double bond arrangement, you can create the conjugated molecule. And if you made long enough conjugated molecule, that molecule homo-LUMO gap, basically the filled orbital and empty orbital, that homo-LUMO gaps comes in the range of semiconductor, and we can exploit that molecules as a organic semiconductor. And there are specific advantage for organic semiconductor, which you will realize when I go through my talk. So basically, if we see the organic polymers, if we consider the organic polymers generally consider as a insulator. For example, if you take the cable, so you will have this colored coating on the cable. That colored plastic coating is nothing but is a insulating coating made from the organic polymer. That is our first image of organic polymer. That should be the insulator. But these three people, Professor McDermott, Shirakawa and Higer, they have done seminal work on the conjugated polymers, and what they have shown that if we take the conjugated polymer and oxidize this polymer or reduce this polymer, they can sustain some charges on it, and they are able to conduct the electricity as much as your normal metal like copper. And that was basically the start of this whole field of conjugated polymer and conducting polymer. Now, when they propose this conducting nature of the polymer, the behind of this conducting polymer, there was a nature that is basically initial pristine molecule which has a semiconducting nature. And this semiconducting properties of conjugated molecules had opened many important fields in the application, and these particular applications are like a devices, organic field effect transistor, organic light emitting diode and organic solar cell. And if you consider the conducting properties of these conjugated molecules, we can have the various applications like battery, supercapacitor and so on. So what is we basically think of about this molecule, that we can make the organic semiconductor. An organic molecule in principle have the flexibility than inorganic system. So we can create basically flexible organic electronic devices, and we can see this is one of the example of organic electronic device, that is a field effect transistor made from organic molecule. So that's why it's called OFET, organic field effect transistor. And you can see from this slide there are various applications for this particular organic field effect transistor devices. So main thing of this organic field effect transistor is basically the organic molecule, organic conjugated molecule. And for the specific need, we need to basically design the specific molecule and synthesize in the lab. So our lab main work is basically to design the organic molecule, conjugated molecule, and synthesize them in the lab, and then we basically collaborate with device people, physicists, to make the devices. And I will tell you the journey through my slides. So when we think of conjugated system and you want to make the polymeric system, the very simple polymer is basically having the chain of carbon where each carbon will be sp2 hybridized, and that each carbon, if sp2 hybridized, it will make long chain where you have double bond, single bond, double bond, like you go from ethylene butadiene and hexatriene, octatetraene, like that. That is the simplest polymer. That was the first discovery made by the Shirakawa and McDermott and Higer. But one of the major problem is that molecule called polyacetylene. And major problem with polyacetylene is this inherent instability. If you expose this molecule to the air, it will be oxidized by the air, oxygen in the air. And then within 5 minutes, this whole polymer will be destroyed. Yeah? So to overcome that instability issue, what we can take, we can take basically two single bond, double bond arrangement and put one heteroatom like sulfur and then make the polymer. So in that sense, we get basically the new kind of polymer, that is this polythiophene, what is mentioned here, PT. So if you basically put Google search for polythiophene, you may get some lakhs of hints about the polythiophene. Why is it important? Because polythiophene is ambient stable, air stable. So you can make the devices out of it. And then lot of work has been done on polythiophene. So this I have shown in the bottom, it's a few examples. This is one of the example where you have mentioned as poly-3-hexyl thiophene. So this poly-3-hexyl, do we have a better this? Yeah, it is working, but it's very light. Okay. So what I wanted to mention here, this poly-3-hexyl thiophene, here you can see in the bottom, it's mentioned P3HT, and this P3HT is basically poly 3-hexyl thiophene. Now when we mention the numbering of thiophene ring, you start from the sulfur, and then you have sulfur 1, 2, 3. 3 position you have alkyl chain, and you make the polymer, that is the poly 3-hexyl thiophene. So why we need this hexyl group on 3 position? Because when you take the thiophene, make dimer, trimer, tetramer, pentamer, its solubility goes on reducing. And when you make the hexamer, it's nearly sparingly soluble, and more than hexamer, it will be insoluble. If you are making organic material and if they are insoluble, it's of no use. Yeah, because you cannot process it. To make it soluble, you need some solubilizing group. So this hexyl group is basically the one of the solubilizing group. Now when you make this polymer, hexyl polymer, you get very nice property, and this hexyl chain interdigitate in the solid state when it packs together, and that gives a nice arrangement of this molecule. And in that case, we need this hexyl group each time at 3 position, and such kind of arrangement we call regio-regular. So if we have the regio-regular poly 3-hexyl thiophene, it makes nice arrangement and give the good properties. So what I wanted to mention here, I will skip some slides here, but what I mentioned in the just now, that if you have this polymer chain with a hexyl group, thus interdigitate very nicely as shown in the picture, and you will have the layers of this one. Now when you use this molecule as a material in organic electronics, so organic electronic device is based on the transport of charges, either it can be the hole or the electron, yeah? And this transport need a very nice arrangement of the molecule. In inorganic system, like silicon is very it's a workhorse of the electronics, yeah, because silicon is a 3-dimensional very nice packed structure, and you get very nice mobility of hole and electron. But organic system is not like that. Inherent property of organic system is randomness. It can arrange very randomly this polymer. But if you want to arrange nicely, you need to put the substituent at very specific page, and this is. But if you want to make this polymer, one situation I can mention here, that if you start with this 3-hexyl thiophene, if you make the dimer, you will get 3 combination as shown in the slide, and if you make trimer, you will get 4 combination, and if you make the polymer, there is a numerous combination, and that will be random. That's called the regio-random polymer, and this kind of polymer will not be useful. Now if you want to make this 3-hexyl thiophene polymer, you need the specific synthetic strategy to make this polymer, because you need to control the regio-regularity in the polymer. That means you need proper coupling reaction, which will. So what we wanted to make, now if you see this 3-hexyl thiophene, this molecule is, if you take the thiophene molecule and put the mirror in the middle, so it is unsymmetrical. But let's say you put the 2 alkyl group, then it looks very symmetrical, and then there will be no question of regio-regularity. So that was the first question we started with, asking that you put the 2 methyl group and make the dimer, trimer. But you see, then what we did, we have taken this trimer, which is shown in the blue color, and then we optimize this molecule. Yeah? So when we optimize this molecule, we see that one thiophene is going like this, second is going, third is going. That means due to the steric bulk of this methyl group, is not in the plane, is basically deviating from the plane, and that deviation will give the less conjugation, and then you will not have conjugated polymer. Yeah? So what is the solution if you want to put the 2 substituent? So we came up with the solution that if you put the 2 substituent in the form of 5-membered ring, it will make the nice pocket of this 2 CH2 group, one from the one side of thiophene ring. because when this thiophene arrange the polymer, one thiophene is up, another down, then up and down, and then you have this 5-membered ring with CH2 group. It's nicely make the pocket and your sulfur will sit there. So you will get the planarity in the polymer. That's what we have basically seen in the calculation, and by considering this aspect, we then thought of the synthetic strategy to make this polymer. So you can see in the next slide, this was our strategy, that you make basically, you take two acetylene, make together, make the metalol. Metalol basically react with sulfur and seleniating reagent. You kick out the metal and you will get the thiophene. Now if you have in the below, I have seen 2 acetylene unit, but this is connected through the 3 carbon chain. Now if you use 3 carbon chain, when you form the ring, it will give you the cyclopentane substitution and thiophene. And that's what exactly we have done in the synthetic way. My student, first student, Saumyajit, when he joined my lab, he basically worked on this scheme and he made it successful. And now this student is already faculty in IIT Ropar. Right now he is doing better than me in terms of research and guiding the students. So that means when you have the student who is doing better than you, that means you are successful. Yeah. So you have to produce the student who will do better work and better research and better teaching than you. Okay, so that was strategy we have made, and we have synthesized this thiophene ring by using this 2 acetylene unit. Obviously we need to do this organic manipulation to put the proper substitution, and 5-membered ring, you can see we have substituted again at the middle carbon, so again symmetry will be maintained. And then we have basically what we do when we make any monomer of conjugated polymer, we study this monomer by using the electrochemistry. Yeah. So particularly if you have the 5-membered ring, which is the electron rich heterocycle. So if you have heterocycle, you divide into part. One is electron rich heterocycle like thiophene, furan, pyrrole, and then you have electron deficient heterocycle like pyridine and 6-membered corresponding heterocycle. So this heterocycle, as in nature they are more electron rich, it's easy to oxidize. Now if you take the thiophene ring and take out the 1 electron by using the electrochemical system. So if you are taking out 1 electron, it will form radical cation, yeah? Because you have the cationic charge, also you made the 1 unpaired electron. And these 2 radical cation combined together form the dimer. Dimer will form tetramer and will go on, and it will give the polymerization, and that process called electrochemical polymerization of this conjugated system. So when we do electrochemical polymerization in presence of electrode, so this polymer deposit on the electrode surface. So this will be electrode coated conjugated polymer, and that polymer you can basically study on that electrode by using the electrochemistry. And if you want to study that polymer by using photochemistry, then spectroscopy, photospectroscopy, then you have to use the transparent electrode. So for that you can use the ITO coated glass electrode, and you can coat this polymer. Now in this next picture, you can see this particular video where we have basically this selenophene particularly. Here we replace the sulfur with selenium. When we replace sulfur with selenium, selenium has a larger size, it's more polarizable. Yeah? And your selenium carbon bond is longer than selenium sulfur bond. As a result, it loses its aromatic character by some extent compared to the thiophene. So when you reduce the aromatic character, and if you have long conjugated chain, it increases quinoidal character. So quinone in principle is more conjugated than your aromatic structure. So this basically, in that sense, selenophene is more conjugated, polyselenophene is more conjugated, and indeed when we see these 2 polymer, polythiophene and polyselenophene, polyselenophene has nearly 0.2 electron hole less homolumo or band gap for the polymer. Now you can see this is our spectroelectrochemistry study. So in this one, what we did, we have taken this polymer which is coated on this ITO electrode and put the electrode, I mean if you put connection with the electrochemistry instrument, and that cuvette, that we have done in the cuvette, and that cuvette we kept in the spectrophotometer. And then by changing the potential, so we have basically plot this particular graph, which is the absorption graph, but in the right hand side we have shown the various potentials. So you can see at some point of time your polymer get oxidized and it form the cationic charge. We generally in the language of solid state physics we call it a polaronic species, and then we get the dicationic species, that is a basically bipolaronic species. And this polaronic and bipolaronic species is responsible for carrying the charges. Yeah? So that way it can make the conducting. So in principle, when we have this polymer and when we oxidize it, from this absorption you can see it's losing absorption in the visible region and getting the new band corresponding to the cationic and dicationic species in the NIR region or the IR region. So that way this polymer is not absorbing, it's becoming basically transparent to the visible light. And in that video you can see when you oxidize it become transparent, and when it is in neutral state it's basically colored. So it's basically again it's a chromic property, and we are using the electrical signal to observe this chromicity. So it's basically electrochromic material. So this kind of material basically already in the market people are using on the this window panes, particularly if you have some high application window panes where you need at some point of time transparency, and sometimes like your curtain, yeah, you make the curtain which is electrical curtain. Yeah? So that kind of application we can think of for this conjugated system. And then this is again something about the synthesis. What initially we thought of strategy that we will make the 5-membered ring through the metal hole. So instead of that, when the student Abhijit, he was basically doing BSc in Professor Chandak's college, and then he later on joined my lab as a PhD student. Right now he is in Hebrew University, Jerusalem. He is doing his postdoc. So he came up with idea that can we, if we have this basically 2-acetylene, we can use the radical approach. Basically, you create the radical on first acetylene, and which will react and will give you the cascade reaction. In that cascade reaction, your sulfur should have the 2 electron which will share with the 2 carbon. So it will be formation of thiophene ring. And for that we have basically chose this thioacetic acid and created the radical by using this AIBN, which is a radical initiator. So AIBN basically split into the 2 carbon based radical which take out 1 proton, 1 hydrogen from thioacetic acid, and this thioacetic acid cascade in the cascade way react with this 2-acetylene and form the thiophene ring. Yeah. So we have also made very nice strategy, and later on we published this paper in the organic letter. So that was basically more about the synthesis. So what we have seen in this example, that if you create basically proper design the proper way your organic system, it can be good conjugated system for organic electronics. To show the some application, we have collaborated with Professor K.S. Narayan from this Jawaharlal Nehru Institute, Bangalore, and he basically done a lot of study. You can see this picture here on the right hand side. This was basically field effect transistor devices, and in one of the study, what we have done, we have basically taken this trimer where we have this 5-membered substituted thiophene, again 2 thiophene substituted. Now you have terthiophene. Terthiophene, again thiophene is the electron rich system. This will be electron rich conjugated system. Now we wanted to make combination of electron rich and electron deficient system. So for that one we have chosen this particular 3 unit of conjugation, conjugated system, which has the electron accepting property. For example, in first case you can see there is a nitrogen sulfur bond which is connected through the imine bond that basically takes the electron out, that electron withdrawing group. Now this donor and acceptor we have coupled together by using the palladium base coupling, and then we get 3 different polymer. Yeah? Now 3 different polymer, if we check the colors of these 3 different polymer, is basically these are the 3 legs of your color diagram, no? Green, blue and red. Now if you have these 3 colors, you can mix these 3 color and create all the colors. That's what basically electronic theory said, that if we have 3 basic color, you can mix together and get. So again, this is basically the in the perspective of what we can see through the organic chemist. So why we are getting these 3 color basically, if we see this 3 molecule, this there is one triazine system. This is a basically it's a benzotriazine, and then you have benzothiodiazole and benzoselenodiazole. So these 3 different unit has a different extent of electron withdrawing power, and that basically change your absorption property. Now you can see in the next slide, if you see this triazole system, it does not have much electron withdrawing proper, and that way we don't have the charge transfer band in the absorption study. So you can see this red color graph. There is only one peak in the absorption. Yeah? That means it's only coming from the conjugation, and there is very little contribution from the donor acceptor charge transferred band. Yeah? So, but in second case and third case, where you have the thiodiazole and selenodiazole, you have basically 2 bands. That means second band, which is the higher wavelength band, that is coming from the charge transfer nature of this molecule. So when we excite this molecule, there is a transfer of charge from donor to acceptor. Now this extent of charge transfer, that also decides the intensity of the. So in principle, sulfur is more electronegativity. So it can basically stabilize this charge transfer state more strongly than selenium, and that's why you can see this blue higher wavelength peak is higher intensity than your green, and that change in the absorption intensity of these 2 bands create 2 different color. This is basically green and blue. Yeah. Okay, so that's basically summary of this particular part what I have discussed. Now I will take you to the next our journey, which we are right now working on, and this paper we recently published in Chemical Science. This is the journal from the RSC. What we have done, we have created again this thiophene based conjugated system, but here we have incorporated this pyrazino-quinoxaline system. So why we wanted to use this pyrazino-quinoxaline system? So we wanted to basically use the acyl molecule. Acyl molecule means it's a basically fused benzene rings, like your benzene, naphthalene, and then anthracene, tetracene, pentacene. So that kind of system, they have basically good semiconducting property. So what we can do, if we incorporate the nitrogen in place of some of the carbon, as nitrogen is a more electronegative, is all molecular orbital of the molecule will lower in energy due to the more electronegativity of it. So that way we can tune basically your HOMO and LUMO level. So if you have higher HOMO level, which will be closer to the work function of your electrode in the devices, then it's basically can transport the charge through electron. And if it is close to the HOMO level, LUMO level, then it can transport the charge through hole. So hole devices will basically p-type devices, and if you are transporting charge through electron, then it will be n-type devices. So most of the organic molecule basically suited for the p-type devices, because organic molecules can be oxidized easily, but they have very less electron affinity. Putting electron on the organic molecule makes it more destabilized. So there is a less number of examples of n-type of devices. So we wanted to use our synthetic design strategy to make more n-type of material, or ambipolar. Ambipolar means they can show p as well as n type of material, where you have your Fermi level in between your conduction band and your Fermi level of semiconductor will be close to the work function of your metal electrode. Yeah, and we need to have the trade-off there. So it will be close to the conduction band as well as the valence band. That means close to the HOMO as well as LUMO. So in principle, it should be in between work function of electrode. It should be in between HOMO and LUMO. And that kind of molecule can. Sorry, I should show this slide here. So what I was talking, this is diagram basically. You can see in the left hand side it's a diagram for the p type of semiconductor, and right hand side n type of, and that if you have the work function in between your HOMO and LUMO, that will give you the ambipolar type of system. And that's what we wanted to make this one. And then my student, this is just introduction what we can do. Particularly if you take this anthracene and put your 1 nitrogen and then 2 nitrogen, its HOMO LUMO basically goes down. It's become more stable to oxidation. Okay, so what we have wanted to do, we wanted to make this pyrazino-quinoxaline system. So Jasmine basically work on this scheme. She has done a lot of work on this one. You can see that there are many synthetic steps, and if you want to create the first molecule where we start, that is also the 2-3 step synthesis. So that way we could able to make both of this molecule. Now when we make this molecule, we do the characterization of this molecule in various ways by doing NMR, mass and all these things. But what we wanted to do, we wanted to see the more fascinating characters of this molecule, and that we can study through the single crystal X-ray. So you can see this picture we have created by taking the single crystal X-ray data, and then we got the crystal structure of this molecule. Now we have very excellent crystallographer in your institute, Professor Malla Reddy, and he worked on the organic molecule, organic crystals, which shows the flexibility. In principle, if you consider the organic molecule, for example, crystal of sugar or crystal of salt, you will not think of that crystal of sugar or crystal of organic molecule. You will not think that crystal will be flexible. Ne? But in some molecule, if you choose the proper group and proper substituent on the molecule, that can give you the flexibility in the crystal. So you can see when we this is just what we do initially, the cyclic voltammetry of this molecule, and then we also try to electropolymerize this one. And you can see this first molecule we could not electropolymerize. What we write here, DPTTQ, that molecule we could not electropolymerize, but DTPQ, what is next molecule, that we could polymerize one. So we were confused that there is also thiophene in this molecule, is also thiophene. Then what we thought we should, and then this you can see when we do the polymerization, each cycle of cyclic voltammetry, you will get more anodic as well as cathodic current. And this anodic cathodic current will be linearly spaced. So that linearity basically tells us that our resulting polymer is basically electroactive polymer. From this, seeing this graph, we can see this molecule is electroactive or not. And it also tells about this, it's undergoing a polymerization process or not. So by seeing this one, then what we did simple DFT calculation, look at the HOMO and LUMO. Now if your oxidation process is going, that means one electron you are taking out from the HOMO, then you have to look at the HOMO. Now if you see the HOMO of both molecule, you can see that there is electron density only on the thiophene rings which are in the vertical direction. I can show you the structure again, I can show you the structure again. Your vertical direction, there is phenyl ring here, and say next molecule thiophene. And where your HOMO density is, your HOMO density is at phenyl or thiophene. Now you see the thiophene, which is on vertical axis, that thiophene is only active for the electropolymerization. Generally phenyl ring is hesitant due to the basically thiophene is a more electron rich, it can be easily oxidized and form the polymer. That way your only the second molecule is undergoing the polymerization, where you have the phenyl that do not give the polymerization. So by doing simple DFT calculation, we can basically predict the properties or explain our observation which we find in the experiment. So next what we did, when we crystallized this molecule, we got nice long needle shaped crystal, and then we collaborated with Professor Molla Reddy. We wanted to study the mechanical properties of this crystal. And now you can see in the next slide, these two different first molecule, you can see there is a phenyl group, and in the second molecule there is a thiophene ring. So when you have the phenyl containing crystal, and when you take this crystal using the forceps and you see through the optical microscope, first crystal is basically brittle, is breaking very easily. But you can see second crystal is nicely bending and is coming back to its original position. So that is basically flexibility we can get from some of the crystals of organic molecule, if you basically put your structure properly. And then we analyze this structure by seeing the packing of this molecule in 3 dimensions. What happens when you have the conjugated molecules, they basically make the pi stacking. So if you have the pi stacking in particular fashion, for example, if you have pi stacking molecule going in this fashion, and this arrangement we generally call the herringbone arrangement. So when you have this herringbone type of arrangement, there will be some region of this packing where your shear forces can be balanced, and in that case your molecule can become flexible, and that's what exactly what we have basically seen in this particular. So I am not expert on this one, but you can, when you read this part or see this crystal, you can realize by seeing the 3-dimensional packing of these crystals. Okay, so what we thought that this can we use this flexibility in making the flexible organic electronic devices. So when again we collaborated with Professor Sena Naik from NISCR Bhubaneswar, and he basically studied this molecule. For example, when he studied this molecule, he made the device. You can see in the bottom picture there is a device, and this device is made on the PET surface, that means polymer surface, and that device we can fold it. So by folding many times, he has seen the conductivity of this particular device is made up of this crystal, and you can see in the second case your conductivity of the device remaining consistent after folding many times, many cycles. But the first molecule which we have seen, indeed it was a brittle crystals, that basically loses conductivity. That means you are losing basically the electronic property of this molecule in the devices. And then also, then further we have done this organic field effector study of this one, and we also study the mobility of these molecules by using the Ssjc method. So indeed this molecule, what we thought initially, these are the basically both property, N type as well as P type, what we call basically, and this is some data which I think is difficult to present here, but I will go ahead and will tell a small, Professor, I have time, some 5 minutes? Okay, so I will tell very short another story. Started with this molecule. You can see there is a phenazine structure where two thiophene are fused with this one. You have phenazine and two benzothiophene molecule is coupled this one. What we have done in this case, we have basically synthesized these two molecules, and synthesis was simple. It's a shift-based reaction. You take this dione. Making dione is basically 2-3 steps. But once you make dione, you react with phenylenediamine, diamine, and this make you the this conjugated system. And we wanted to study this conjugated system. And one of the aim is to make this acin type of conjugated system and study their property. So again, you can see this molecule has a and we also wanted to have to study the structure property relationship. So in that case, what we did, in one case we have put these two thiophene in one direction. So you can see this first structure where syn is written, so your thiophene is downward direction, and where anti is written, your both thiophene is upward direction. Yeah? So we wanted to study the placement of this thiophene ring or sulfur atom with electronic properties. And from this molecular structure, you can see this both molecule has a similar kind of HOMO and LUMO. Yeah, that means we can expect the similar electronic properties from this one. But going ahead, what we have seen that in the literature, they are also mentioned that if you have similar kind of arrangement of a similar kind of electron density distributed in HOMO and LUMO, they will pack similarly in the crystal structure. And indeed, when we see this, both the structure basically packed in the this space group, which called P212121, and this is a non-centrosymmetrical space group. Non-centrosymmetrical space group basically give us some special properties to the crystal. Most of the organic crystal you will have symmetrical space group. Very few crystals will have the non-centrosymmetric space group, and that create some specific property, specific electronic property to the molecule. I will show in the next slide. So they have similar kind of packing, but you can see again these crystals, they have a flexible nature. So this flexible nature means you can take this crystal, bend it, and it can come back again to the original position. So further studying the property, again when we see the organic molecule, we always basically think of the fluorescent molecule. One of the electronic properties is fluorescence of this molecule. So to check this fluorescence nature of the molecule, what we do, we drop 1 drop of solution on TLC plate and put into the UV chamber. Yeah? So if you see fluorescence, then if it fluoresces, then it will be fluorescent molecule, otherwise it is not. Now you can see from these two structure, very similar structure, very similar HOMO-LUMO electron coefficient density, but by changing the orientation you are getting the different fluorescent property. And then we can, once you observe, we can explain basically. In the second structure you have nitrogen and sulfur very close to each other. So there is a basically possibility giving the nitrogen lone pair electron density to the sulfur carbon anti-bonding sigma star orbital, and that basically twinge your pathway of fluorescence, one of the possible reason for this observation. But what we wanted to pursue this fluorescence molecule, and for that again we have collaborated with a group of Professor S. Chandrasekhar, from University of Hyderabad, Central University, and he is the expert on the photonic devices. So what he did, he basically, but before sending this sample, what we did, we have taken this crystal and shine in the middle with laser. If you take the crystal, shine in the middle, and if you see the glow at the end of this crystal, that means these crystals can act as a waveguide. Waveguide means you shine the light, that crystal will carry light at the end of this crystal. So it can act as a waveguide, and it has various physics application. Professor Dobre may know these photonic devices and then application of this particular. So I collaborated with Professor. So he's seen that when you record the emission property at the end of crystal by shining in the middle, you can get similar kind of emission spectra. So for example, you can see this original emission spectrum was blue color, and you can see at the end of crystal your red color. Yeah. So what happened, due to this non-centrosymmetric nature of the packing of the molecule, whatever energy, light energy is absorbing, it's basically transferred to other molecule, and that way after absorbing it's emit. But this emission is not immediate emission, it goes to the next molecule, next molecule, next molecule. That way it's basically propagated and is guide this wave of light to the end of the crystal. And that's what basically explore in these devices. So what Chandrasekhar has done, basically he made the devices, very unique kind of devices, very first time he made it. He take these two crystals, and these crystals are flexible. Then he made the coupler by coupling these two crystals bent to each other. And then this is called evanescent coupling. Evanescent coupling means just physical coupling. There is no chemical attachment between the two crystals. And when he shine one of the end of the crystal, he can see that out of the three ends, he can get the two ends of two crystal, your output light. Yeah? So it's basically, it's a multiplexing of your waves. Yeah? So it can be used in this wavelength multiplexing devices. So that will be the next part, but we wanted to have the basic study, and he studied these devices in more detail, and we published this paper in very good journal, Ssjc Chemie International Edition. And with this one, I want to conclude my talk. So what we did, we have basically, we are synthetic organic chemists, and we wanted to make the new fascinating molecule for the application. And our main aim is to basically make the conjugated molecule for the application in organic electronic devices. And to some extent, we could get some of the good molecule. So let me thank the funding agency, DST, CSIR, and DRDO, my students, postdocs, and collaborator. One of the collaborators is sitting here, Professor Hemant Chandak. And this is the group, and then I should these are some pictures of my institute. One of the research building where I have lab in the first picture. Second is the auditorium. Third one is basically the teaching complex where we have the classrooms. And at the last, I thank you all. I will be happy to.
So yes, thank you, Professor Zade. It's indeed a pleasure for me to be to chair the session by a scientist who is a son of our soil. He is a son of Vidarbha, born and brought up in Amravati region. It was really a pleasure to chair the session. Professor Zade, we will definitely have one or two questions, but before that I would like to comment on it, and then we can have the questions. Guruli sir, is that okay? Yeah. We can have one or two questions. I will have my concluding comment first, and then we can have a couple of questions.
So, Professor Ssjc started his session by setting a tone, starting from the thought of inorganic semiconductors to organic semiconductors, where he talked about polyacetylene moieties and very simple phenomena that extension of conjugation can lead to the difference in the band gap, homo-lumo gap. This is what he has explained, and the title of the talk, which was centered around tuning the electronic and the what you call electronic properties of the molecule by the structural engineering of an organic molecule. This is what he is based on, and Dr. Ssjc is also a very good example of, because I know he did his PhD at IIT Bombay, and the PhD was centered around organoselenium chemistry. So eventually during his postdoc he extended the work with Mikhail Bendikov at Israel, and there he gradually moved from an hardcore synthetic organic chemistry to a material chemist to some extent. So thank you, Professor Ssjc. You also talked about the one more important point that we noticed from your talk was, before going for the synthesis, you always did some quantum mechanical calculations. So, and these DFT calculations helped a lot in predicting the properties of a compound. Especially, I was very impressed to know the way you saw the electronics of the molecule using the DFT. So, where the electronic coefficient is more and less in the HOMO and LUMO, that particular gives us a guidance to do for the synthesis. You also talked about the electrochromic material, and I know, I believe that was a serendipitous discovery probably. Maybe you are doing electrochemical polymerization and you saw color. Probably that could be the case, but it is again a wonderful finding that a scientist should have. He should be always curious to observe what is happening in the lab. Many times we also get flexible crystal, but we throw it. We don't bother about it. But you nicely elaborated how flexible crystals can be exploited further for the different application. And obviously this has resulted in some of the good recent publications, one of them in AnguChem, another one in chemical science. So once again, thank you, Professor Ssjc. And in the interest of time, I request the participants to have 1 or 2 quick questions. Gurunur sir, please.
So nice presentation. Just I have a doubt that you have synthesized the conjugated polymers, and they are showing these flexible and semiconductor natures. Is it possible for other polymers, for example, graft polymers or block copolymers like that?
Yeah, that is true. Block polymer and block copolymer is basically one of the kind of polymer where you can
it also conjugation is also there.
You can make basically block polymer can be conjugated as well as non-conjugated. So if you want to make, let's say, block conjugated polymer, so you can take one thiophene block and then you will have some method of living polymerization, and then you can attach the second block, maybe the polyselenophene or other something. So that way, and there is some report in the literature that we can make the block polymer by using this living polymerization. Particularly if we use the Kumada type of coupling, that gives you the living polymerization. This is basically magnesium based coupling using the palladium DPP kind of ligand, and that basically gives you the living polymerization. And indeed this block copolymer is more interesting than the simple copolymer that gives you the different electronic properties, and we can explore further.
Okay, thank you.
No more questions. So thank you, organizers, for giving me opportunity to chair the session. Thank you.
Thank you, sir. I feel great honor and privilege to take vote thanks on this session. I extend my warm welcome to Professor Ssjc sir for excellent talk on flexible molecular electronics from a perspective of molecular structure. Also, extend my warm regard to Professor Chandak sir for chairing the session and concluding the sessions. And I also also very thankful for all the professors, UG students, PhD scholar for attending the session. Thank you very much. The technical session 1 is over here. Now I hand over the mic to Dr. Atul Nagpure sir for technical session 2.
Good afternoon to all. It gives me an immense pleasure to stand before you in a one-day national seminar on recent trend in material science for sustainable development. It's a pleasure and honor to conduct technical session because we have with us none other than Honorable Professor Sanjay Dhobre sir as speakers on this occasion. I kindly request Chairperson of this session, Professor Gurnule sir, Kamala Nehru College, Nagpur, to please chair this session. It takes me honored and I welcome Professor Dhobre sir as a speaker on this technical session. I request both our dignitaries on the dais. I feel happy to welcome both of these gems and star galaxies in the scientific community. I take privilege to welcome Honorable Professor Gurnule sir. I kindly request Professor Deshmukh sir, Principal RMG College, Nagpur, to welcome Professor Gurnule sir with bouquet, token of love from Ssjc College, ARJUNI MORGAON and RMG College, Nagpur. Thank you very much, sir. You have made our day. I also kindly request Gode sir to welcome Professor Dhobre sir. Dhobre sir is a well-known personality in the scientific community in India as well as in abroad as well. I take privilege to read a few lines about Professor Dhobre sir. I know that it takes one day for me and I had hard efforts to coincide his CV. Professor Dhobre sir did his PhD in 1992 in solid state physics from Nagpur University, Nagpur. He has visited many countries: Italy, Egypt, Japan, Australia, Hong Kong, South Africa, South Korea, UK, Greece, China, Sweden, Malaysia for academic cooperation. He having abundant experience in UG and PG level. One of the most important point here, he has more than 1,000 research papers published as Scopus publications, along with citation more than 15,000. He has guided, I am putting in inverted comma, he has guided 78 students. I am sure that many more in a pipeline. He has received 2.5 crore research grant from DST, CSIR, UGC, IUAC, and so on. Notably, Professor Dhobre sir name considered as top 0.05% in a scholar GPT at world level at 2024. Furthermore, if I add, Professor Dhobre sir is a top 2% scientist in the world in the year 2020, 21, 22, 23, 24. I am sure again he will be the top 2% scientist in 25 as well. He has a fellow of Luminescence Society of India, fellow of Master Academy of Science. He receives many research awards, national as well as international level. He has published numerous research articles in a reputed international journal, including ACS, RSC, Ville, elsewhere, and so on. He is the editor of many renowned journals. I am sure that you will get important star from his galaxy. Myself, I consider him as a galaxy of knowledge. With this few words, I hand over this session to Professor Honorable Dhobade sir, and I am sure that he having that abundant strength that he will inspire you, a future generation. Thank you very much.
Thank you, sir, for your nice introduction about the Professor Dhobade sir. The topic is on the topic. Sir is going to discuss on the multidisciplinary sciences, and I invite on this occasion, as we know the what is the biodata about the Dhobade sir, well known to all, great scientist, great professor, and it is privilege of the college and of all of us that he is present here. I am going to deliver on the topic multidisciplinary sciences. So I request Professor Dhobade sir, please deliver your the presentation. Sir, start.
Thank you for introduction for me. I'm very happy to present my work here. My work just is the total interdisciplinary work, as well as I want to motivate MSc students and new teachers. They are just entered in the research field. So I will try to explain my work on the topic of So my topic is novel material for science and technology. But this material in field of the luminescence, and any material emit the light by any process, this material is called the phosphor. So first, what is the luminescence? What is the phosphor is very important. So I will try to explain the luminescence material, and it is called the phosphor. So just you can see this electron present in the ground state, and this electron absorb energy from the external sources. So this is the excited and reach at the higher energy level. At higher energy level and reach at the n equal to 2. So this electron reach at the higher energy level n equal to 2, and then this electron is not possible present to here long time. Again come back to this electron, excited electron in the ground level, and in this process, this emission of this light in terms of the photon, and this is called the luminescence. So this is the simple way of the luminescence explanation. So now application of luminescence are, just you can see the so many type of the application, just the lamp, laser, discover. So just you can see this is the different number of luminescence, and if you try to work on this, so this is very important. So now again just I'm trying to explain some of the application of the street light, indoor plant, biomedical application in this one, and Wi-Fi also. So my meaning is the application of this material are in the different field, different subject. So if I'm preparing the material and find out its characterization, and if this characterization for the particular type of the application, so we are trying to work our work to the different subject. So then I'm consider this is my topic in the interdisciplinary work. So just I'm explaining the different topic, and I'm working in the same time all this topic. This is the application of LED for artificial lighting, enhancement of the solar cell efficiency, TL radiation dosimetry, INBB radiation, plant cultivation with the botany, fingerprint for the forensic, long lasting and road traffic safety, biosensor with the botany, microbiology, antimicrobial activity with the microbiology, biochemistry, phototherapy, it is the completely pharmacy, mosquitoes repellent, it is also biological base, and machine learning of phosphor is the computer base, and geology material in the radiation dosimetry in the geology department, fabrication of the biomedical devices, fabrication of devices of Ayurveda, and sociology, political science, and history also. So I am working with all these subjects, and I am publish the paper, patent, chapter, and book also. This is the we have. So I am just explaining everything to here. I am trying to. So first, prepare the material by the different techniques, solid state, wet chemical, and novel synthesis. So as per the facility available in the laboratory, just see the combustion synthesis, very simple technique. Just all nitrate based compound you can fire at the 550 degrees centigrade. And then this compound heat the at 1500 to 1600 degrees centigrade, and this compound is completely prepared to here with this flame, and thus we can use the different fuel that is possible, the different morphology of this material. Now different fuel you can use in this material, so morphology of this material also changes. So just synthesis depending on the luminescence application also possible with help of this. It is very interesting, as well as to see the second method is the soldier technique. This soldier combustion technique is only for the specific for the nanomaterial synthesis. So just you can see the all nitrate compound activator and tetraethoxyarthosilicate you can fuse with the ammonia, and then same is the combustion technique. By this technique only for the nanomaterials are prepared. So this is the very important and one. Now this solid state diffusion technique, it is a completely rough and tough technique. You can use the carbonate, oxide, any type of the starting compound. So it is possible you can prepare this compound by a double heating method. One is the 500 degree, one is the higher temperature 1000 degree. But this compound material is the micron size. It is not possible to the nanomaterial. And this is the very simple, and this is the very economical also. This is the weight capital. Just you can see, this is the double distilled water and borosil, and just you can prepare, then is possible. But sometime nowadays it is very important for the waste material you can use for the synthesis. Just eggshell, it is the content of the calcium carbonate. So if you have prepared the calcium based compound, then eggshell is also important. You can prepare the silicate material. So this is the rice husk, it is also possible. So sometimes we are trying to prepare some of the compound with the, this is the waste material, and this is very important for the preparation. This is the power saving, and this is very important. So now if you can prepare the material, inorganic material, so then it is characterization by the spectrophorophotometer in my laboratory available. Thermoluminescence, it is also available. UV visible, and this is the spin coated for the different purpose. So this apparatus is initially for the luminescent characterization. Now, but you can see this is the magnetic stirrer, solar simulator, high temperature, centrifuge machine, then all this is the synthesis. But some of the very costly apparatus is not possible in the every laboratory, just the XRD, scanning electron microscope, or TEM, and all these things. So this is the possible, you can, the collaboration or against the payment, this is the characterization is possible. So with help, all the apparatus are required for the characterization. Now I am discussing some of the application of the phosphor. So I am first trying to explain the artificial lighting. So artificial lighting, it is the LED lighting, it is very important. It is completely eco-friendly, it does not contain any type of the mercury, and then this is the, I am concentrated only for the artificial lighting, it is the LED material. So just you can see it is the total lifetime is the 1 lakh hours, and it does not contain any type of the mercury. So this is the eco-friendly. As well as to see this is the 90% power saving. So as compared to the tungsten filament, mercury based lighting or other lighting, this is the very economical, and this is the eco-friendly. So this type of the lighting is very important nowadays. But for this white light preparation, it is the blue, green, and red is combined with the white light. For our two color LED also available in the market, And this two color it is requires a blue and yellow only. Both mixing, it is also possible emission of the white color. So for this or three color, you can excited by the UV light or near UV. Near UV means it is a 350 nanometer to 400 nanometer, or you can excite the blue LED also for the prepare this excitation. So this is the color required. So in my laboratory, I am working on the preparation of this different phosphor, and then we have particular ratio according to the intensity. It is converted in the white light emission. So just you can see here, tricolor and its LED and LEDC. So blue, green, red, it is the emission of the white color. So all this type of the LED available in the market, but it is the phosphor is very required. So in our laboratory prepare that this is the different material under the normal light, but you can excite it in near UV light. So blue, green and red, it is the combined limit the white color. So how to prepare this material is very different. Though our mainly periodic table, I'm just concentrated on this the lanthanide based or rare earth based material are here mentioned here. But all element, it is not possible for the preparation. So just we are considered some of the one is the European, CE, DY, TB, and SM. It is the band gap is very successful for the preparation of the LED material. Then I'm selecting only for the some of the element here, and host material anyone I'm working aluminate, borate, silicate, phosphate, anyone available in the lab or as per the reference literature or the according to the application. So just you can see here. So what is the excitation source? Near UV excitation source, it is very difficult. So indium gallium nitrate with the different composition of the indium. So X value you can change, that emission also changes in the near UV. 395, again the 405, 460. This is the very useful. It is the excitation. It is easily available in the market, but in the phosphor preparation is very difficult. This is the one of the phosphor prepare. Sorry, one of the phosphor prepare. I'm just here. And then it is the structure is this much, and it is the dope with the European in 3+, in the 2+ and 3+ state, but 3+ then is the red emission, Assam 3+, it is the blue, violet, yellow emission, and PR is the blue, is combinedly also possible to emit the white color. And this figure, it is called the graphical abstract. If you want to publish your paper in the high impact factor, so graphical abstract is very important. So whole your paper, you can imagine and you can trace the one figure. This is the best one figure for the graphical abstract, and if this figure is like this one, then easily accepted. So now just you can see one of the phosphor prepared here, the SR3 AL8 SiO7U2+. So then the excitation is the 354 nanometer. It is the only the near UV, and this is the emission in the completely. You can see here in the blue color of the spectrum. So this is the emission on this material. So this is the one of the blue phosphor out of the three colors. Now just you can see this is the second phosphor, it is the SR3 AL8 SiO17 U3+. If you enter in the 3+, then emission in the red color of the spectrum, and this paper by the Soldier method. So just you can see this is the emission at the 612 nanometer due to the 5D027 transition, and this is the completely red color, and then this is the one of the phosphor useful. So this is the normal light, this is the under UV light, this is the red color. Now on question of the green color. So SR3Al2O5Cl2, TB3+ is the green phosphor, and just you can see this is the emission in the green one, and all this combined three phosphor white light emission is possible. Nowadays, if anybody interested to work in the LED, then these points are very important. How to enhance the intensity, how to prepare the non-toxic inorganic material, how to prepare the low cost material. So this is, you can change the combination of the excitation emission, wavelength, chemical root synthesis, as per the mentioned earlier, starting material and heat treatment. So nowadays it is a very important for the color tuning phosphor, and this color tuning phosphor, it is the controlling the dopant level of activator as well as sensitizer, varying the concentration of the sensitizer and activator, as well as the combination of the emission and different type of the host. Just is the in your compound of the VO4, you can replace with the BO3, MO4, WO4, BO4. So this is called the replacement of the host material, and that color emission is the shifted. That this is called the color tuning. But just you can see here the cation substitution, anion substitution are both also possible. So with help of this all this parameter, you can change and you can possible the prepare the very good phosphor. for the coloring. Just see the one of the materials here, BAMG pure voltaics U2+. This is the emission in the blue color only for the single peak. But you can, this PO4 you can replace by this BO3 with a different concentration. That this peak is the decreasing, another peak is developed. So at the x equal to 1, this both peak are the same. And then in this case only for the this peak is deleted and only one peak. So this peak is shifted, but this x equal to 1, this is the single material emitted 2 color. This is very important, and this process is called the color tuning. This is also one of the graphical abstract for the very high quality research paper published in the Journal of Allied Compounds by my student. And now just you can see this is the SR3GDL3BO3 and this material is prepared. Just this is the very important, just you can see here. So this is the emission in the red region, and just you can find this is the red compound are here, other 2 standard compound, and completely you can observe the white color, and this is the white LED. So what is the my target? Only one material, if emit the 3 color with the help of the different activator, so that this is the success of this my research. So presently I observed one material, and this material is like this one. I am not mentioned this name, this is the patentized material. And then it shows that all 3 colors in the same time in the single host material, and just try to compare this material with this already. So my single material is show the total white light emission. So then it is also submit for the patent, and this type of the very important for the new research for the patentization. So this is a very great success in the field of the luminescence. So now this is the one of the applications. Second application, just in the science and technology, if you have published the research paper, so research paper in the one impact factor in the Scopus and Thomson Reuters impact factor is very interesting, but you have published your paper in the peer reviewed or UGC, it is not very interesting. So research publication they do not require any single pi, but some of the people show that sir हमें paper publish करना है Scopus में लेकिन पैसा लगता है. कौन बोलता है पैसा लगता है? Today I have my total 981 paper on the Scopus, I have not paid any single money. So if your paper is the one impact factor, the Thomson Reuters and Scopus indexes, that this is a very good research, you can explain. So just you can see this is one of my paper is the 1 point something impact factor, 1.335. So this is by one of my students, this is Scopus indexing, that this is very interesting. You will try to publish the again higher impact factor, is the 2 impact factor. So that again just you can see this is the very interesting, this is also Scopus indexing and Thomson Reuters. Now in the third paper, just is the by this one, 3.806, and this is again one of the students. And now my student is always try to publish, this is the one student who published the Nature publication. My student paper is also published in the Nature with my collaborator Alexander Crispy for England. And this is the Karan Kumar Gupta, presently working in the Taiwan as a postdoc fellow. So if you can publish the good paper with the student, that they are easily get the postdoc fellowship, just as mentioned in our earlier program. So then this is the possible. And this paper is the published in Nature, is the very high quality paper. So now just you can see the again next paper is the 406. Now Ssjc sir is mentioned the RSC and ACS is very important publication for the chemistry people. So I am also trying to publish the paper in the ACS and RSC. This paper in the RSC and this is one of my collaborator Ashish Tiwari is helped collaborate with this publish this one. Yeah. Okay. Second, just this is the 4.172. This is the Govind Nair. This student now presently in the postdoc fellowship in the South Africa. So you can always try to publish the very good paper in this one. Just this is the paper again ACS by this Ashish Tiwari in the ACS, American Chemical Society. That these all paper are very interesting to can publish in the high level. So now next is the inorganic chemistry by the Bhushan Kore with my collaborator is the this is the SWOT and it is impact factor the 5436. This Bhushan Kore it is a very small story I want to share with you. ये आपके पौनी के पास के एक छोटे से गांव का है. ये जब MSc में हमारे डिपार्टमेंट में आया था तो मैंने उसको थोड़ा मोटिवेट किया और ये यूनिवर्सिटी टॉपर आया. उसके बाद मैंने मेरे पास बियारनेस का प्रोजेक्ट था उसकी फेलोशिप दी मैंने उसको और उसको साउथ अफ्रीका में पोस्ट डॉक के लिए भेजा. उस पोस्ट डॉक करते करते इसने एक कोठारी फेलोशिप मिली और IISc जो बेंगलोर जो इंडिया का टॉप मोस्ट इंस्टीट्यूट है उसमें 3 साल जॉब मिला. सो कोई हमारा स्टूडेंट IISc बेंगलोर में जाता है तो उसको हमें कितना खुशी होती होगी. वो भी एक गाँव का लड़का. सो ये बहुत है. उसके बाद उसने करने के बाद स्वीडन गया, अब अभी जर्मनी में कर रहा है. इसकी एक ऐसी और एक स्टोरी मेरे साथ जो जुड़ी है, मैं बहुत उसको स्टोरी को मोटिवेट मानता हूँ बाकी लोगों के लिए जो बैठे हैं। जब हम बाबा एटॉमिक रिसर्च सेंटर गए थे तब हमने वहाँ पे जो बहुत सी सिक्योरिटी रहते हैं, जब ब्रेकफास्ट करके गए और अंदर गए तो 1:30 बजे वहाँ के एक साइंटिस्ट BC भट्ट सर ने बोला, डोबले सर आपके स्टूडेंट को लेके चलो खाना खाने। मैंने चले यार भूषण खाना खाते हैं। वो बोले सर भूख नहीं है, सवेरे तो खाना खाया था। मैंने सवेरे तो ब्रेकफास्ट किया था। नहीं, बोला हमको भूख ही नहीं। मैंने क्यों, कभी ब्रेकफास्ट करता नहीं क्या? सर बोले हमारे पास पैसे ही नहीं रहते। ऐसा स्टूडेंट 3 कंट्री में पोस्ट डॉक किया और उसका आज 5 लाख रुपीज़ पर मंथ फेलोशिप है। इससे अच्छा आनंद मेरी रिसर्च को क्या मिल सकता है। इसलिए मैं आप सभी स्टूडेंट को बोलता हूँ, जो गांव के स्टूडेंट होते हैं बहुत एनर्जेटिक होते हैं, बहुत मेहनती होते हैं। पौनी के पास छोटे से गांव का, शायद गुरु सर को नाम पता होगा, छोटा सा गांव मुझे, और वो बहुत गरीब घर का है। और दैट इज सो अगेन दिस इज द भूषण कोरे आल्सो पब्लिश दिस पेपर 5.436 in the inorganic chemistry. Now just you can see this is the 6.2 impact factor. This is a very good paper in the chemical biology. This is the biological paper. Just you can see this is the microbiology student published this paper in the 6.2 impact factor. Now just you can see again this is another paper, the 6.31C. Yes, sabhi paper I am one of the author with my student and collaborator. So now this is the 7.613. मैं इसलिए आपको बता रहा हूँ कि जो बैठे हैं उनको ये ना लगा कि स्कोपस में पेपर पब्लिश करना कोई कठिन बात है. इट इज़ वेरी इजी बट यू कैन वर्क हार्ड एंड यू कैन सिक्वेंशली एंड लिंक में होना चाहिए. So now next one paper again is the 7.7 by this A.R. Kadam. Now this is the again 8.389. It is the again high impact factor in the progress in solid state science. Now this is the paper the 10 in the nature group. So again nature group में भी एक अच्छा पेपर हमने पब्लिश किया. So now next paper the 16.799. This is the renewable sustainable view. This is V.B. Paude is now presently working the assistant professor in the LIT University. So ऐसे पब्लिक पेपर करने के बाद you can get the job in the higher institute level. Now this is the Kalyani. This is also 16.779. He is also assistant professor in the LIT University Nagpur. So then this is the very good paper. Again this is the 16.77. Now again I am trying to move the upward. So now next paper is the 31.6 impact factor. ये आपका माइक्रो लेटर में this is the one of the my collaborator. It is the K Park is the South Korea collaborator, and this is the Karthik Shinde is published a very good paper, and this is a very high impact factor. But after that I am always try to again how to is this possible to improve your impact factor, so you can work with the student as a friendly, so that is possible. So now I am trying to this paper is the 48.165 progress in material by going higher, and now this is a very interesting, and this is 2020 paper this published, but after 3 years again this impact factor repeat in my lab by this Manoj Mehre and Chaitali Mehre with my collaborator Ssjc. This is again 48.16 impact factor. So this is the very nice. So you can publish the very high impact factor, always possible. It is not any difficult, but you can work hard. जैसे मैंने आपको पहले बताया, anybody interested to publish this type of paper, I am always available for this. Now, therefore, my 16 students get the postdoc fellowship in the abroad. Okay, and some of the patent also. I have published the totally 92 patents. Out of this, the 53 patents are granted. So if you are presently my PhD student already published the paper. Here is the Sharad Deshmukh sir sitting in this hall in this same college. My professor he published the 2 patents and 3rd patent in the process. So this is the very interesting phosphor for another solar cell efficiency. This is very interesting enhancement of the solar. So this phosphor peak is the under the solar spectra. So then it is the directly transfer the energy to this solar panel, more photon, and just I will try to enhance the efficiency more than the 20. Here the 20% is efficiency. So then I am just by this Dr. Blade method prepare this one, and just this is the solar cell purchased in the market, and this one is coated on the solar cell like this another figure, and then it is the efficiency, it is the enhancement, and just this is the measurement of the CI diagram in my laboratory. And now just you can see after the preparation of this one, just this is the efficiency increased by the 35% in the solar cell, and direct sunlight is the 37.73%. So is the 20 plus 3.7 is the 23.7. So one is increase is very difficult, and per increase is 35%. So this is the power saving is the new technology material. So also possible in this one. And this paper is a 6.317, and then again is a good paper also publishing on this the solar cell efficiency. Now next material, this is the calcium vanadium phosphate is a triple doping DY/TB and U3+ prepared by this mentioned this technique, solid state diffusion method, and this is the peak in the under the, again this is the completely this URI, and just you can see it is the efficiency increased by the 43.33%. It is very good. So 20 plus 4 is the 24%. Silicon cell efficiency enhancement. So this is a very interesting material, and then it is a paper also published 7.613, and this is a very good quality, and this is the, some of the patent also different material in this mild replay. Now phosphor power display devices. This is the another application of this material for LED phosphor power display devices. Just you can see this is the LED material, and this LED material useful for the display. So is the display is possible according to this picture. Then you can prepare the different type of phosphor, efficient phosphor, and it is the decay time is the change. Then it is useful for display devices. Now phosphor power long lasting and road safety. So just you can see here. Yeah. So this is the strontium magnesium silicate. It is the decay time up to the only 120 seconds. But you can co-dope in this material U2 plus. You can dope with the DY3 plus. Then it is the decay time increase up to the 8 minutes. So then corresponding it is the efficiency again in the increasing, and then this is useful for this road safety like this this type of the signal. So now this all this material are very interesting, and some of the paper also published. Now this is a very interesting phosphor for radiation dosimetry. Radiation dose measurement. Just you can treat your body during the cancer patient. So you can expose by the gamma ray, and this gamma ray directly penetrated your body. So normal cell is also affected with the cancer cell is also possibility, but 26 exposure required for the killing the cancer cell. So surrounding or bottom side is also cell is damaged. So you can measure the dose for the gamma ray. So this thermoluminescence technique useful. So this is the thermoluminescence technique is the required this the characteristic. I am not going to the display all this. Just you can see this is my main topic of the research is the high quality of a paper. And just you can see this is the one of the material K3Na isophoroltase U2 plus prepared in this material, and just this material is prepared by the evaporation method as well as to the melt method. So and this European enter in the different host lattice that corresponding of this material characteristic also the changes. So this is the material we can compare with the BRC. So this XRD pattern of the evaporation material is well matched, but this melt method it is the two-phase material, but this two-phase material is more sensitive of the gamma radiation. This is the repeat number of times, and then it is confirmed this method for the particular two-phase material, and it is the peak position is the simple, it is useful for the one, and it is the intensity the 6 times higher with the standard material, and this standard material is prepared by the Bhabha Atomic Research Center. So university people also try to prepare the good material as compared to the national laboratory by our students. So this is the response curve of this. Just glow curve changes, not changes, but you can see here response curve. This is the BRC material, standard one, and this is our lab material. This is the 6 times higher. Then you can measure the very small dose by this or measure material. So this material is very interesting, and TL emission also blue color. And if you want to publish your paper in the high impact factor, that decay characteristic, or again is possible, and this material useful like this the TLD batches. So this batch you can put in your pocket or in your rings or watch, and then you can work in the radiation dosimetry. So and this is the some of the paper are published to on this one. So just the dinosaurs fossil. I am going to the just visit for the geology department or university, and just the one of the piece of stone are here. मैंने बोला मैडम ये क्या है? बोले डायनासोर का अंडा है, बहुत साल पुराना है. मैंने थोड़ा सा दो ना. अब मैंने जब भी बताया कि मैं एकेडमिक भीख मंगा हूँ, चोर हूँ, तो मैंने उन्होंने थोड़ा सा पीस दे दिया, तो मैंने उसको कैरेक्टराइजेशन किया. सो दिस इज द यूजफुल फॉर द हाई डोज डॉसिमेट्री. So then this is the dinosaur fossil useful for the dosimetry, and this paper is published the 2.9 impact factor. After that, on second visit, I just give the turtle also some small piece, and it is also high dose dosimetry. It is also published in the Scopus paper in the 2.9 impact factor. So just phosphor for the ion beam radiation. This is very important. If you want to change the structure of your material according to the application, then you can expose by the ionization radiation different ion. That possibly it is possible. This is the facility available in the Inter-University Accelerator Center, Navi Delhi, and my collaboration already is developed there. And in this one, this is the bragg peak is very useful, and this is carbon bragg peak, that carbon particle reach up to the cancer cell and release the whole energy to cancer cell, and they are damaged. But normal tissue is not affected. So carbon particles are very useful for the cancer therapy. And then just you can see here some of the paper. This is the irradiation source in the vacuum chamber, and our material put here just like in this position. So just you can see in the chamber, just you can put this sample to here, and just this type of the material put on this vessel, and then this is put inside the gamma chamber, carbon 6 particle chamber, and then it is possible to irradiate, and then it's possible. This is the ionization radiation. Our material is the TB3 plus, that blue emission. Our material, it is the U2 plus dope, that is the blue emission, and therefore this is very useful. And this is the published, the paper is like this one with the different collaboration. This is a paper on the cancer treatment is the cancer 6 plus ion radiation. So this you can cover also your work with the biological side also, and then biological people also try to work in this with this. So very important. Now this Nature publication only for the, this is the carbon 6 particle by Karan Gupta, and now this is the, again so many paper and published on this source. Now up conversion nanoparticle for cancer therapy. Now this is the submitted 1 crore project with the pharmacy people, pharmacy collaborator. So now here just you can see this upconversion material, you can excite your material in the higher wavelength, then emission in the lower wavelength side, and this emission in the near UV radiation, NIR radiation. This NIR radiation is 880 nanometer light. So this is the directly kill the cancer cell, and our protein cell is the damage, so cancer cell you can recover. So according to the emission wavelength of our material, and that corresponding is the different application, and that's corresponding we have prepared the material, and you can find out the different applications. So therefore is very interesting. So this is the directly you can see this is the one, and it is the reactive oxygen species, and then damage this protein, and here is the is completely damages. So then this is very important. Just you can pass this one is the localize the liver one. So 980 nanometer injected in the nude side. So then here completely remove. So then this is the technique very useful for the cancer treatment of the nanoparticle. And some of the material developed in my laboratory, and it is with this good material for this cancer therapy. So that this topic also very interesting, and some of the good paper is work. Now correction exposure during the radiation treatment of cancer patient. 3 students working in the cancer hospital working with me. So suppose your body exposed the gamma radiation or carbon 6 radiation. So this dose measurement with the source and the cancer cell. So, but during the excitation, this body like this one, so half or 1 inch this body up and down. So dose is not properly treat this cancer cell. So some of the correction, and this correction I find out in the cancer hospital with this one. So this is the completely biological based material, and very good paper is published by this is the Prashant Shinde, and second is the one Ravindra Shinde in the Raipur, Prashant Shinde in the National Cancer Hospital, and very good results are possible. So this work also possible with the radiation. Now phosphor for antimicrobial. This is a microbiology student, biochemistry student, or biotechnology student possible to work here. So just you can see the copper nanoparticle. Copper is the very interesting to show that this is the completely my one chapter, one talk on this one. This is the agal marble, means bel ki patti. Bel ki patti say if you have prepared this nanomaterial by green synthesis. So this type of the XRD observed, this is the only possible for the nanomaterial. And just you can see this is the size of this material is the 16 nanometer. Less than to the 10 nanometer, it is called the quantum dot, but this is near to. So this is very effective. And just you can see this material, it is create the well damage to the different bacteria. Then we are consider this particle are very useful for the antimicrobial activity, and then it is useful for the healing purpose. It is useful for the some cosmetic device. So directly biomedical or cosmetic technology application. So some 2 cosmetic technology madam also working with this me, and this is the one of my students, the Shruti Tanwar is working on this one, and this is the very good result you can observe like this. Now illuminate nanoparticle also, Al2O2 nanoparticle also prepared by this green synthesis. It's a particle size the 73, and this particle is show the very good microbial activity, and then this is also an antimicrobial activity. So now this is very interesting. Now this is the phosphor for plant cultivation. Means if any plant is not possible at our place, just as some of the plant in the Gadchiroli medicine plant, some of the Karnataka, but if you have prepared this, grow this plant in our place, so you can expose this plant by particular atmosphere by artificial lighting. So the far red means 650 nanometer and above, this light, it is enhance the efficiency of this material, but and then this possible, this type of the plant at your place. So now just you can see, this is the total far radiation, 430 to this is the 520, it is the photosynthesis clear, 950 to 600 phototropism, and 630 to 750 for the enhance the fertilization rate as well as to the growth of the plant. So this is a very interesting color, and we have prepared this material in my laboratory. Just you can see this is this one. So this is the far red region is very important, and now this is the material is published by the very good person, and then 693. So you can develop this type of the greenhouse at your place. अभी तक आपने देखा होगा ग्रीन हाउस देखे होंगे जिसमें प्लांट को ग्रोथ करते हैं, but this greenhouse you can expose by the LED light. Till date I am not observed in India, but abroad there is so many type of the greenhouse. So this is the technology transfer to farmer in the Samudrapur College Vidya Vikas with my collaborator botany the head Naina Shirbhate. So this is the one of the project also with us by Naina Shirbhate, and this is the technology only transfer. So just you can see this is the very interesting and very small place, just is the number of slide. So number of plant, then you can grow this one, but it is the उसकी भी ज़्यादा से ज़्यादा application है. ये आपका है एस्ट्रोनॉट, ये एस्ट्रोनॉट आपको फॉरेन में कितना रहा, जस्ट आप देखिएगा 229 दिन 8 आवर 41 मिनट स्पेस में रहा. जब मैंने इससे मुलाकात हुई, हो सकती है होती है, तो जब मैंने इससे मुलाकात की भाई इतने दिन ऊपर में क्या खाया, तो बोले आर्टिफिशियल LED से प्लांट ग्रोथ करके हमने खाया है, और रिसर्च के में इतना दम होता है कि अपन बड़े बड़े लोगों से मिल सकते हैं. और आई एम जस्ट डिस्कस विद दिस पर्सन, आई एम विद दिस ऑस्ट्रेलिया सिडनी, एंड देन दिस इज द टोटल. तो मैंने ये इसको केवल एक न्यूज़ देखी मुझे पेपर में, और अकॉर्डिंग टू आई एम प्लान माई वर्क, तो मुझे जहाँ से भी मैं एक्साइट होता हूँ उसको हकीकत में चेंज करता हूँ. ये मेरी आदत है, अच्छी आदत है, आप भी अपने इसमें लगा लीजिएगा. सो जस्ट दिस इज द स्पेस डिवाइस फॉर द ग्रोथ ऑफ दिस प्लांट, एंड नाउ इज फॉर, एंड दिस इज वेरी नाइस न्यूज इन द लोकमत. सूर्याचा ने LED जगमगात पिकेल शेट्टी, दिस इज द नैना शिरभाते एंड माई सेल्फ. So this is the very good news, and therefore just, and this is the some of the paper on the same plant with the madam from the botany department. Just you can see like this one, one or two pattern also with this madam. Now this is a very difficult research. If you have this cow, you can expose by the LED light, but 16 hours, so its milk increased by the 8%. And find out which wavelength affect this increase in the wavelength milk quantity, so that find out, and this research is going on with the agriculture department. So this is also application of phosphor. So phosphor is the multidisciplinary work, and I am trying to find out this one. Just you can see this is the very important work. Now phosphor for phototherapy. On the screen, you have the 48 type of the disorder, red or black, white spot आते. You can expose by the 314 nanometer by GD3 pen emission. उससे अगर expose करेंगे तो this spot is very clear. So this is that it is very useful for the phototherapy, like this one. So just you can see this is the spot. This is a different type of the psoriasis on the skin, and just we will try to expose this psoriasis by 311 to 15 nanometer, and this emission possible by the GD3, but this is called the UVB light. So जितना spectrum है UV से लेके NR तक, I am trying to working develop in my material by different synthesis route, different host, different activator. So I am totally broad spectrum this one. So this is the UV light useful for this purpose. And this is the one of the material prepared in my laboratory, and it is published with a very good impact factor. So that nowadays you can expose the one piece. This is called the target therapy also. So this is the target therapy, which does not require the whole body exposure. Newborn baby also you can expose and control the hyperbilirubinemia. So this is the biological part, but work with by physics people. So now this is very interesting. Now this is some of the paper is published on this, like this one. Now first part for night vision lamp. This is the very defense. So NRL light directly useful for detect the in the night vision. Just you can see this is the spectrum, and if here the NR1 is the 750 to 1000 nanometer, NR2 is the 1000 to 1500, NR3 is the 15 to 118. So this light useful for the take the image of the, and this material already show the activator show this type of the emission. So I am working on this material, and this car is present to here, and this detect this person for the long distance, and you can give your idea, and this is the different type of the device is possible by this NR light. So different wavelength, different light are also possible. Just this photograph is possible only by this light, and it is useful for the defense purpose also. You can take, and this is the mechanism of the night vision lamp. So my work is also going on this one. This is useful for the defense purpose. So all these applications are very important for this the night vision lamp, and this is one of the material prepared in the laboratory, and it is the emission is the 1536 nanometer light. So now this is the very useful for the prepare of this material, and just photograph you can see like this one. This is the daylight and in the night vision. Now first part for mosquitoes repellent. This is the work with the sir. Just the Ozola plant is repellent this one, but just I password the yellow color is repelled the light lamp yellow color. So now this is the, just you can see this is the yellow color light emission developed in laboratory, and if you can prepare indicate this one, so it is the mosquitoes also the repellent. So this emission 574 nanometer is very difficult to identify this one, but it is possible to prepare the repel these mosquitoes, and this is the very interesting work done by MSc student, my student. All this बड़ी खोज LED की पीली रोशनी से भागेंगे मच. जब ये फोटो पेपर में आता है तो उसके माँ बाप को कितनी खुशी होगी आप अंदाज लगा लीजिएगा. ये जो लड़का है ये बोलते हैं कि आजकल मेरे बाप को मेरे नाम से जानने लगे. ये इसकी दैनिक भास्कर की फ्रंटलाइन न्यूज़ थी. सो आई एम ट्राई टू द मोटिवेट माई ऑल स्टूडेंट MSc and PhD. और मैं आपको बता दूँ आज की डेट में जितने भी मेरे लैब में MSc के स्टूडेंट हैं, PhD के स्टूडेंट, सबके मिनिमम 2 पेटेंट हैं. वो कंपलसरी है, वो करते ही है. सर मेरे पास आइडिया है, मालूम नहीं कहाँ से आता है, तो फिर मैं उसको एलाबोरेट करता हूँ, साइंटिफिकली करता हूँ और फिर पेटेंट में कन्वर्ट करता हूँ. सो ऑल दिस न्यूज़ इज द सोर्स ऑफ एनर्जी ऑफ माई स्टूडेंट. नाउ दिस इज द ओजोला प्लांट. जब मैं यहाँ पे आया तो मैं जब बताया कि ओजोला प्लांट इट इज द रिपल्टेंट द मॉस्किटोज इज द एब्जॉर्ब द कार्बन डाइऑक्साइड एंड ऑक्सीजन इमिट करता है. सो इससे जो इस समय नागपुर में ये चल रहा था चिकनगुनिया और का बहुत ज़्यादा प्रॉब्लम था. सो मैंने इसको बताया कि दिस प्लांट इज़ वेरी यूजफुल, यू कैन ग्रो एट योर हाउस. सो वहाँ के नागपुर के पत्रकारों ने इतनी अच्छी न्यूज़ बनाई. तो ये अपने देशमुख सर है, ये आपके पीछे में 3rd रो में बैठे हुए हैं. पहली बार बेचारे का फोटो पेपर में आया, बहुत अच्छा लगा मुझे कि हम किसी के लिए कुछ तो भी एनर्जी दे सके. और देन दिस ये कॉलेज को भी हुआ और इसको हमको 2 पेटेंट मिले हैं. सो दिस इज एजुला मॉस्किटोज फंड करेल डासा और नियंत्रण. सो दिस इज वेरी इंटरेस्टिंग टू वर्क इन रिप्रेजेंट बाय द हितवाद आल्सो. और क्या चाहिए हमें, हितवाद से ज़्यादा और न्यूज़ कौन दे सकता है, हितवाद लोकमत. So now some of the paper also published. Now luminescence biosensor. Luminescence biosensor, it is the, just you can see this is the photograph, blue bacteria near to the sea level. So this blue bacteria, so I'm just working with the biotechnology person, and 2 bacteria collected from the Goa sea, and then it is the registered by name and biotechnology teacher name, and just is the this one is the place, and isolated this and affected, find out the reason exposed by the gamma radiation, alpha radiation, beta effect. Then this is called the biosensor. So ये बायोसेंसर का पेपर हमने उसके साथ निकाला, और ये जो रिसर्च स्टूडेंट ने भेजा उसका ऐसा न्यूज़ आया. उससे क्या इफेक्ट होता है, इस स्टूडेंट को दूसरे दिन ही जॉब का ऑफर आया और वो आज अच्छे जॉब कर रही है. दिस इज द बायोटेक्नोलॉजी स्टूडेंट, वर्क विद, आई एम को गाइड ऑफ हर, एंड शनिवारे मैडम इज द गाइड. So then this is the very interesting. Now phosphor for fingerprint. Phosphor for fingerprint for the just forensic application. Just you can see this phosphor just like this one. This is the phosphor material, but its particle size less than to this distance. It has so many technical points. I already work on this one, and some of the material show this is the good paper. So this is the application of this one. Now computer science is the machine learning. Yes, do minutes. Computer science is the machine learning. This is the machine learning is to predict the emission wavelength and excitation wavelength. This is the good paper. And this Vijay L. Bari, it is the software engineer. ऐसे हम बैठे थे चाय पीते, और बोले तुम इतना काम करते हो मैं भी कुछ करूँगा, करना भैया, किसका मना किया। तो उसने मुझे 1.5 साल में मशीन लर्निंग सिखा, 1.5 साल में उसको लुमिनेशन सिखा दिया। तो ये 2 पेपर हमारे अच्छे पब्लिश हुए। Now this upcoming first for cancer therapy, for synthesis of phosphor of nanoscale and find the biological application. This is a very good work. And now research in Ayurveda. आप बोले Ayurveda में भी, just you can see 8 type of the basti, and this useful for the panchakarma. जैसे घुटने का प्रॉब्लम होता है, some of the like this one. So this basti is the treatment is the like this one. तो उडदाची डाळ असते, त्याचं आळं करतात, त्याच्यामध्ये तेल टाकतात, त्याला गरम करतात, त्याच्यामध्ये पर्कुलेट होतं आणि आतली नस फ्री होते. पण तो म्हणे सर आमच्याकडे लोक येतच नाही, आज आले 4 दिवस नाही, 4 दिवस आले 15 दिवस, काय प्रॉब्लेम असतात गावातल्या लोकांचे. म्हणजे तुम्ही काय करा, पण सर आयुर्वेदिक डॉक्टर तुम्ही, मी फिजिक्सवाला काय करू. मी म्हटलं ठीक करून देतो मी. सर त्याच्यावर डिव्हाइस बनवले आणि ह्या सगळ्यावर मी पेटेंट काढलेला आहे. दिस इज द वन ऑफ द डिव्हाइस इन द जानू बस्ती. 1 पेटेंट ऑन दिस वन. दिस ऑटोमेटिक सिंगल मैन हैंडेड, उसको दूसरा हैंडेड नहीं. यहाँ तक तो ठीक है घुटने का था, लेकिन जब ये दिस इज द पेटेंट पब्लिश हुआ, और ये दिस इज द 2 आयुर्वेदिक डॉक्टर विथ मी. एंड नाउ नेक्स्ट इज द वेरी डिफिकल्ट द कटी बस्ती, जो पीठ का दर्द होता है उसके लिए सिंगल मैन हैंडेड. इट इज़ वेरी डिफिकल्ट फॉर मी, लेकिन हमने उसको भी किया, ये डिज़ाइन बनाया. और नाउ दिस इज द पेटेंट, इट इज पेटेंटाइज दिस मटेरियल, or is completely working with this patent also granted. And now this one madam and this myself. So all this work is possible. This is the Hridaya Basti. This is also patentized, this material Hridaya Basti. And this Basti with the another madam with the Datta Mege Ayurvedic College, Wardha. Now in Manya Basti, it is also working on this under a process. इसका patent होने का है, इसलिए मैंने इसका display नहीं कर रहा हूँ. But all this 3 Jahanu Basti and this is the Varna Basti. So all this patent is work with the different people. These 3 बस्ती here, माना बस्ती, हानु बस्ती, वर्णा. जब मैंने सोचा कि मैं फिजिक्स वाला हूँ, हर बस्ती के लिए अलग डिवाइस कैसा रहेगा, एक ही डिवाइस बनाना चाहिए, तो मैंने बना लिया और उसको एक ही मल्टीपल बस्ती करके उसको एक ही डिवाइस बनाया. दिस मच, दिस इज डायरेक्टली यूजफुल फॉर दिस. और उसमें मुझे पेटेंट भी मिल गया, ये पेटेंट भी मिल गया उसको. So then this is the very interesting. And now just you can see all this person develop the different type of this one. So उसके कारण वेद प्रकाश मिश्रा जी ने मुझे मेडिकल कॉलेज में, एकेडमिक कॉलेज में एक्सपर्ट करके ले लिया. तो फिजिक्स वाले को मेडिकल में लेना यार कोई ईश्वर आशीर्वाद दे वैसा ही बात होती, इसलिए ईश्वर आके बैठ गए यहाँ पे, तो मैं उनकी बहुत शुक्रिया अदा करता हूँ. सो दैट दिस इज अ वेरी गुड प्लेस फॉर मी. एंड नाउ जस्ट यू कैन सी, ये रिसेंट वाला है. जब न्यूज़ पढ़ी मैंने आरटीओ की कि एक गाड़ी के दोनों पर्सन के लिए हेलमेट रहेंगे. ठीक है, आरटीओ अपने लिए काम करता है, ओके नो प्रॉब्लम, लेकिन दूसरा हेलमेट रखेंगे गाड़ी में, एक ही हेलमेट रखने की जरूरत होती है. सो वेर यू पुट द सेकंड हेलमेट. तो मैंने विचार किया, मेरे और जब भी मेरे को कोई आइडिया आता मैं एमएससी या मेरे रिसर्च कॉलेज का शेयर करता हूँ, उनके साथ करता हूँ. मेरे को पगार मेरे स्टूडेंट के लिए मिलता है, मेरे लिए नहीं मिलता. तो देन आई शेयर विद द आदित्य देशमुख एंड देन डिजाइन दिस पेटेंट एंड इट इज द ग्रांटेड. और इसका अभी 2-3 कंपनी हम पास अप्रोच हुई है. आई होप 5-6 महीने में ये पेटेंट इसका आ जाएगा. So all this the helmet घड़ी करून वाहनात ठेवता येईल. So this is the very interesting and this is the Times of India news. और क्या चाहिए हमारे स्टूडेंट को. So therefore I am working on these things. So when मैं गुरुल सर से रिक्वेस्ट करूँगा, सर मुझे 5 मिनट दे दे, मैं बाहर चाय पिला दूंगा आपको. शक्कर के जगह नमक डाल के चाय पिला दूंगा. So this is my paper 981. My H index is the 49, citation the 14,564. Google's पे 56 is the H index, 17,800 और इस साल का citation 527 हो चुका है और I-10 470. So therefore my student, मेरा कोई भी ग्रुप का स्टूडेंट बिना जॉब का नहीं रहता. कोई भी स्टूडेंट कहीं भी जाए वो पेपर पब्लिश करता है और इंजीनियरिंग कॉलेज को बहुत है. इसलिए मैं जब भी बोला कि कोई 10 पेपर या 15 पेपर पब्लिश करे, उसको प्राइवेट यूनिवर्सिटी में 100% जॉब. एक स्टूडेंट मेरा रामदेव बाबा में, एक स्टूडेंट औरंगाबाद में, एक और कहीं है, उसको 90 और 85,000 पेमेंट है सर, केवल पेपर के भरोसे. एक साल में 13 पेपर मेरे साथ करते हैं. हमारे पास सोने का वक्त नहीं होता, हम सब छुट्टियों में काम करते हैं और मेरी लैब हमेशा ओपन रहती है. सो देयरफॉर दिस इज, सो 2 पेपर है द 48, 12 is the 10 to 32. ये डिफरेंट इम्पैक्ट फैक्टर के अलग अलग पेपर्स हैं. दिस इज द वन एंड जस्ट दिस इज द डायरेक्टली स्क्रीन शॉट ऑफ द स्कोपस 14,981. और इस साल मेरे 500 समथिंग पेपर हो चुके हैं. जस्ट 72 इसका पेपर 2024 में थे और इसमें just you can see all this screen right, और total paper every year more than to the 50. तो बहुत अच्छा लगता है भाई, उसको क्लिक कर दो, स्क्रीन पे क्लिक कर. So every year is the paper is more than 50. और एक 2023 में 100 पेपर किए थे, इसलिए न्यूज़ आई थी कि एक ही सत्र में पर 100 पेपर पब्लिश. सो दिस इज द वेरी गुड न्यूज़ फॉर द माई यूनिवर्सिटी. ये मेरे लिए नहीं है, मेरी यूनिवर्सिटी के लिए, मेरे स्टूडेंट के लिए. इससे मेरा स्टूडेंट का लेवल बढ़ता है, स्टूडेंट की डिमांड बढ़ती है और इसलिए वो पोस्ट डॉक फेलोशिप इजीली मिलता है. सो इन कोरोना में हमने सबसे ज़्यादा काम किया था. कोरोना में शांत नहीं बैठे थे और ये करते रहे. ये गूगल स्कॉलर का है कि 17,800 और ये स्क्रीनशॉट है. और ये मटेरियल साइंस का एक न्यूज़ है 24 और 4 में कि टोटल पेपर इसमें सबसे ज़्यादा CNR राव साहब के थे जो उन्होंने यहाँ पे दिया. और सेकंड में साबू थॉमस साहब है जो एक्स वाइस चांसलर थे कोट्टायम में. और मैं थर्ड पे हूँ, तो दोनों साउथ के हैं. इसका मैं अकेला इंडियन बचा, तो इंडिया में महाराष्ट्र में सबसे टॉप पे हूँ और इंडिया में थर्ड पोजीशन पे. सो दिस इज द फर्स्ट पोजीशन CNR राव, सेकंड इज साबू थॉमस, आई एम द फर्स्ट थर्ड, बट महाराष्ट्र में आई एम इन द टॉप पोजीशन. सो अच्छा लगता है. टॉप 2% साइंटिस्ट इन द 20, 21, 22, 23 एंड 24 बाय स्टैनफोर्ड यूनिवर्सिटी. एंड इस साल मेरे गुरु के साथ, मोहरित सर के साथ मेरे को मिला है. आई एम वेरी हैप्पी. एंड फ्रॉम यूनिवर्सिटी लाइवली, मैं अकेला, सर तो रिटायर्ड हो गए 10 साल पहले, बट आई एम वेरी हैप्पी कि मेरे साथ सर को भी इसमें मिला. नाउ टॉप 2% टू रैम जम्प इन द 0.50% बाय स्कॉलर GPS और इसमें मिला है. जस्ट कैन सी दिस इज न्यूज़. और यहाँ पे आप देखिएगा कि इसमें जस्ट द 5th पोजीशन इन दिस लिस्ट. 17 लोगों की लिस्ट है फास्पर में जिसमें मेरा एक नाम है और इंडिया का एकमात्र नाम है उसमें. 17 लोगों की लिस्ट में 0.55 इसमें. सो दिस इज द वेरी इंपॉर्टेंट फॉर द ल्यूमिनेसेंस पीपल. एंड जस्ट यू कैन सी दिस ल्यूमिनेसेंस में 1.01 से भी कम पे है. सो दिस इज द वेरी नाइस. एंड दिस इज द GPS न्यूज़ क्या है. और like this some of the news to I just display to here, or just the 0.05% like this one. तो ऐसे जब न्यूज़ आती है तो अच्छा लगता है. टॉप फैकल्टी रिसर्च अवार्ड 2014 मुझे करियर 36 में मिला था और बेस्ट रिसर्च अवार्ड यूनिवर्सिटी ने 2016 में दिया. LED फास्पर TLD मेरे बेस्ट टॉपिक है. और इफ़ यू कैन सी द डेटा इन द स्कोपस, तो मैं स्कोपस पे टॉप पे हूँ. किसमें, फास्पर पे. सेकंड टॉपिक अगर कीवर्ड आपका LED फास्पर है, आई एम अगेन द टॉप पोजीशन. एंड इफ द फास्पर द TLD फास्पर अगेन आई एम द टॉप पोजीशन इन द ऑन द स्कोपस वेबसाइट. सो देयर इज माय 92 पेटेंट, ग्रांटेड 53 है, पब्लिश 21 है, फाइल इज 18 है. सो दिस इज द टोटल रिकॉर्ड ऑफ दिस माय हो गया. और एकेडमिक पेटेंट आइडिया का फेस्ट हुआ था उस समय मेरा ज़्यादा विदर्भ में सबसे ज़्यादा पेटेंट थे, इसलिए सुरेश भट्ट सभागृह में 4000 लोगों के सामने उप मुख्यमंत्री साहब थे उस समय मेरा उसने सत्कार किया था. सबसे बड़ी बात है कि उसमें जो स्पीच दिया था सर, उसमें उन्होंने बोला था की विदर्भात पण खूप बुद्धिमत्ता आहे आणि त्या ढोबळे सरांचे विदर्भात सर्वात जास्त पेटेंट आहे. आणि त्या ऑडियन्समध्ये माझी बायको बसली होती तेव्हापासून बायको मला रागवत नाही आणि घरातले कामं पण सांगत नाही. काही उपमुख्यमंत्री देवेंद्र फडणवीस सरांनी तुमचं नाव घेतलं 4000 लोकांसमोर. दिस इज द तिच्यासाठी फार आहे. शी इज ऑल्सो प्रिन्सिपल इन द सेवादल महिला महाविद्यालय. MSc PhD आहे ती केमिस्ट्रीमध्ये. सो दिस इज द व्हेरी गुड न्यूज बाय दिस. सो अगेन I am adjunct professor in the some of the university. Now, sorry, I am already visited in this country, Italy, Egypt, Japan, Australia, Hong Kong, South Africa, UK, Greece, China, Sweden, South Africa, Malaysia, and just this is my international and national collaborator. मैं इनके साथ कंटिन्यू मेरा काम है और दे आर ऑलरेडी कभी भी मेरे स्टूडेंट को पोस्ट डॉक के लिए लेते हैं. दिस इज द टोटल फंडिंग प्रोजेक्ट. विजिटिंग फेलो है मैं शिलोंग इसका 78 स्टूडेंट. मैं फेलो ऑफ द ल्यूमिनेसेंस एंड फेलो ऑफ महाराष्ट्र. एंड नाउ दिस इज द इंटरनेशनल बुक है 31. आई एम नॉट गोइंग टू द डिटेल, मैं 2 बस बुक में ख़त्म कर रहा हूँ. और मेरी एक मराठी बुक है यहाँ पे, ये वाली जो अभी NEP के हिसाब से मराठी बुक में मैंने सब स्टोरीज लिखा है और उसको निराली ने पब्लिश किया है और उसको साहित्य विहार से इस साल का फर्स्ट प्राइज़ मिला है साहित्य गौरव साहित्य का. तो इसको भी मराठी में बुक लिखने के बाद फर्स्ट प्राइज़ मिला. विद मानसी कोलती इज़ द वन ऑफ द को ऑथर. वो भी मेरे स्टूडेंट है, जूनियर कॉलेज में काम कर रही है. सो थैंक यू. रिसर्च हमारे इंटरव्यू तो जैसे मेरे अलग अलग चेहरे हैं वैसे अलग अलग सब्जेक्ट है और मैं फिजिक्स वाला इन सभी के साथ भी काम करता हूँ. दिस इज़ माई इंटरडिसिप्लिनरी वर्क. सो सर गुरुले सर ने इतना बड़ा टाइम दिया और मेरे साथ शेयर किया. दिस इज़ द नोबेल प्राइज़ विनर और मुझे अच्छा लग रहा. तो 16 स्टूडेंट PDF और ये सब हो गया। हाँ, एक मेरा स्टूडेंट है जो आपको बताया इज 85,000। इसने सर 1 साल में 13 और 23 पेपर PhD में पब्लिश किए थे। और ये जब उसको इंस्पायर का एक मिला उसको अवार्ड, तो ये LED के नोबेल प्राइज से मिला और 4 लोगों से मिल के आए नोबेल प्राइज से। तो ऐसे कुछ हीरो होते हैं लैब में, तो अच्छा लगता है। नाउ दिस इज द अनदर स्टूडेंट इज द आल्सो इंजीनियरिंग कॉलेज, गुड पेमेंट। एंड नाउ this is the current Gupta is the PDF in the Taiwan. This my 2 students are working in the postdoc fellow in the abroad, and our MSc Physics student also the patent and research. Just you can see इन तीनों को MSc में पेटेंट मिला हुआ है। पेटेंट इसका एक ग्रांट है और 2 और 3 सभी के हैं। ये सेम 4 के हैं और ये 3 स्टूडेंट सेम 1 के हैं, सेम 2 के हैं। So they are very interesting to publish this good paper. Now thank you very much. Just I slip this and some of the awards and now okay. और ये यूनिवर्सिटी का जर्नल है, जिसको भी पेपर पब्लिश करना है आप भेज सकते हैं, विदाउट इम्पैक्ट फैक्टर है, ये पीयर रिव्यूड है। एंड दिस इज माय लेबोरेटरी, सर हमारे लैब में कई बार विजिट कर चुके हैं। एंड माय लैब इज ओपन फॉर कोलैबोरेटर। मैं किसी भी के साथ सब्जेक्ट में काम करता हूँ। एंड रिसर्च लेबोरेटरी इज टेम्पल फॉर मी एंड माय रिसर्च इज पूजा। सो थैंक यू, दिस इज माय रिसर्च कोलैबोरेटर एंड बिग थैंक्स टू माय स्टूडेंट and my all collaborator. This is the, if any want to contact me, this is my mobile number, this is the email ID. So now, thank you very much. So if you have any question.
Thank you, sir, for your wonderful and very informative presentation. Sir has shown everything regarding the different types of phosphor and the applications of this luminescent material in different field, and so no need to also ask any to explain details about that, because in the slide everything is shown, okay, regarding publications, regarding patent and all other activities in general. So because of short time, only one question from the audience. Only one. Yes.
हाँ हाँ, ये तो मेरा कॉमन क्वेश्चन है सर। मैंने आपको बताया था देवेंद्र फडणवीस साहब ने एक बार मेरा नाम लिया, बीबी मेरे को काम नहीं बताती और काम बताया नहीं किया तो भी डांटती नहीं, यही एक कारण है। और मेरी मिसेस एकेडमिक साइड में है, तो मेरे को फुल्ली सपोर्ट करते हैं। और मेरे लैब में ऐसा कल्चर है, स्टूडेंट का आने का भी टाइम नहीं, जाने का भी टाइम, और मेरा भी नहीं है। सो दिस इज द रियल है। और मैं सर शौक करके मैं रिसर्च करता हूँ। मैं यूनिवर्सिटी मैं करूँगा तो यूनिवर्सिटी का होगा, डिपार्टमेंट का होगा, भारत का होगा, कोई ये नहीं है। तो आई एम जस्ट एज ए मेरी हॉबी करके रिसर्च करता हूँ, और उसके बिना मैं रह नहीं पाता। और जब कोई आइडिया आती है देन आई एम स्टार्ट माई रिसर्च रिवर्स इंजीनियरिंग, और उसमें कारण शोधते उसमें पेटेंट बनाता हूँ। दिस इज द रीज़न सर। और मैं 18 आवर्स आज भी काम करता हूँ। तो अच्छा आदत है। हम कमला नेहरू में थे, सर भी कमला नेहरू में थे, हमने कभी छुट्टियाँ देखी नहीं है, ना छुट्टी एंजॉय किए। तो एंजॉयमेंट क्या होता है ये भी पता नहीं है, सही में नहीं पता सर। तो संडे के भी दिन काम करते थे, छुट्टियों में भी काम करते, सर का भी वैसे था। ये सही सच्ची है। और वहाँ से आदत लग गई। अब लड़की को उसके महके में आदत लगी तो ससुराल में वैसे ही रहेंगी ना। मैं कमला नेहरू में ऐसे जैसा रहा वैसे इस डिपार्टमेंट में रहूँगा, कहीं भी नौकरी करो, कोई सवाल नहीं आता। थैंक यू वेरी मच।
सो थैंक यू सर। सर के जो आज का प्रेजेंटेशन था, दैट वी कैन लर्न, student or faculty members also can learn the behind that hard work and sincerely work. If you do, you can get success. This is the we can take from the presentations. Okay, दो ही बातें ध्यान में रखने का है। वो सर का मुझे पता है कि बहुत हार्ड वर्क करते हैं और सिंसियरली करते हैं जो भी काम है। दैट इज द सक्सेस ऑफ दिस ऑल द रिसर्च। तो रिसर्च उन्हें छोड़ा नहीं है, आज अभी भी कंटिन्यू है। एंड सो थैंक यू सर फॉर नाइस प्रेजेंटेशन। And I am also thankful to the organizer for giving me the chance to be a chairperson for this session. Thank you, sir.
सर्वांच्या माहितीसाठी, म्हणजे परवाच्या दिवशी माझ्याकडे विलायतकर सर आले आणि ढोबळे सरांचा जेव्हा टाक होईल तेव्हा चेअरमन कोणी राहायचं असा एक प्रश्न विचारला. आता म्हणजे मला असं वाटतं की 1 वर्षाचा फरक आहे आमच्यामध्ये. सरांपेक्षा मी 1 वर्षांनी सिनियर आहे. आणि सरांचं जे वर्क आहे जे आत्ता तुम्ही बघितलेलं आहे, मग कोण चेअरमन होणार हा माझ्यासमोर फार मोठा प्रश्न होता. आणि मला हे पण माहिती नव्हतं की डॉक्टर वासुदेव गुरनुले या ठिकाणी या इव्हेंटला येणार आहेत. मला आज सकाळी ते माहिती झालं आणि मी विलायतकर सरांना म्हटलं की आपल्याला चेअरमन सापडलेले आहेत. डॉक्टर वासुदेव गुरनुले यांचा प्रत्यक्ष जरी या ठिकाणी टाक झाला नसेल किंवा त्यांच्याविषयी माहिती नसेल, पण ते एक फार मोठे नावाजलेले आपल्या भारतामधले केमिस्ट आहेत. त्यांचं पण वर्क फार मोठं आहे आणि त्याच्यामुळे सरांना जर चेअर करायचं असेल तर डॉक्टर गुरनुले इज परफेक्ट पर्सन असं मला त्या ठिकाणी मी सांगितलं. आणि म्हणून स्पेशली ऑन बिहाफ ऑफ द ऑर्गनायझर्स आय हार्टिली थँक्स टू डॉक्टर गुरनुले सर as well as डॉक्टर ढोबड़े सर.
एक चीज़ रह गई है, मुझे 5 तारीख को 5 बजे स्वर्गीय धरणीधर गांधी अवार्ड मिलने वाला है डॉक्टर गिरीश गांधी फाउंडेशन की तरफ से, जिसमें स्मृति चिन्ह, शाल और 1 लाख रुपए. सोशल वर्क करने के बाद तो परसों के दिन मेरा वो मिलने वाला है. तो जो भी नागपुर में रहेंगे तो प्लीज़ आइएगा. मैं आपसे सबसे रिक्वेस्ट करता हूँ, एक आपके बीच के लोगों को अच्छा अवार्ड मिल रहा है. थैंक यू.
Hello. Thank you, sir. It was indeed a great pleasure to listen. Outstanding scholar. I am sure that by his talk, many electrons, neutrons, protons, fermions, boson could have excited in the mind, and it will give a new path towards excellent scientific journey of India. I take this privilege to present vote of thanks. I extend my great regards to Honorable Professor Dobere sir as well as Professor Gurnere sir for having on this technical session. Furthermore, I would also like to extend my acknowledgement to all the participants, experts, audience, committee, and last not but the least, who has participated directly and indirectly for this session. Thank you very much. Signing off, Dr. Atul Nagpure. Now I hand over this platform to Dr. Manish Matte sir for technical session 3. Dr. Manish Matte sir, RMG College, Nagpur.
Good afternoon, one and all. Esteemed guests, respected speakers, and dear participants. It is my privilege to welcome to you all this one-day national seminar, Recent Trend in the Material Science for Sustainable Developments. In the era where the sustainability is a global priority, material science plays a crucial role in the shaping the innovative and eco-friendly solution. This seminar brings together experts, research and academicians to discuss the latest advancement, challenges and future direction in the material science. Without further delay, let's dive into our promising schedule, engage in the insightful discussion. I kindly request chairperson for the technical session 3rd, Professor Amit Dr. Ahmada, sir. So please come to dais, sir, as a chairperson for the 3rd session. I again kindly request the speaker, sir, please. I again kindly request speaker of the 3rd sessions, Professor Umre sir, VNIT Nagpur. Please take a seat, sir. I request Mr. Gode sir to welcome the chairperson of the today's 3rd session, Professor Ahmad sir. I request Dr. Sarve sir to welcome Professor Umre sir. Sir. Thank you, sir. Professor Umre sir obtained his MSc, PhD, MPhil degree from the Chemistry Department, Nagpur University, Nagpur, and he joined VNIT Nagpur 2002, and now he become as a professor. In 98, he worked as a Sheffield Hallam University, UK, under the UK-India REC bilateral project as a postdoctoral fellow at the Department of Chemistry, IIT Kanpur. His research the research interests of the Dr. Umre sir are solid state chemistry of the polymers, nanomaterials, heterogeneous nanocatalysis, and green chemistry. Dr. Umre sir has executed 5 research projects sponsored by MHRD, UGC, BARNS, and DST. He also credited nearly 95 research articles, including books, chapters in the international scientific and peer-reviewed journals, with the index of IH index of 31 and the 2,968 citations with the 2 books. He has supervised 18 students, and he is also reviewer of several scientific journals. Apart from teaching and the research, he also discharged different administrative responsibility as a head of department, as a member of secretary for the formulation of new chemical engineering course at the VNIT, head of chemical engineering department, coordinator FIST, chief warden and dean in the institute. He delivered 80 lectures in India and involved in the outreach activity for the promotion of the science among the students. In a recognition of the service towards the society and the science, he was admitted as a fellow of Royal Society of the Chemistry by the Royal Society of the Chemistry, Cambridge, United Kingdom, fellow of Indian Society of the Analytical Scientists, Mumbai, and the fellow of Maharashtra Academy of Science, Pune. So I request Dr. Umre sir, please deliver the talk.
Good afternoon, everyone. So you had 2 lectures by Professor Zhade from ISER, Kolkata, and then Professor Dobde. He worked on the various areas. The student, I request all backside student, back chairs, you please come in front. There are many vacant seats. You came here for learning. You are all requested to please occupy the front seats. Back chairs, back students. Come here, come in front. So I'll be working on basically GC3 and 4 material. I'll be working on the GC3 and 4 material, and this is the material which is work for the sustainable development. And before going to talk for a technical this data, I would like to discuss about the environmental issues, because this is the material which is highly used for the environmental application. We know the environmental issues. We have a global warming, climatic change. We have again the air pollution in the many of the metros. And in order to tackle these issues, you know, UN has initiated the global warming, global sustainable goals. There are 17 global sustainable goals. And yes, next slide, please. Next. Okay, so I'll be working on mostly the heterogeneous catalysis used for the various application. I will come here in front. This is basically comfortable for me, and I'll be working on the Sustainable Development Goal 6, which is used for the clean water resources, Sustainable Development Goal for 7 for clean energy and sustainable energy, and Sustainable Development Goal for 13, which is for action for a climatic change. We know the climatic change, this is one of the biggest challenge in the world, and some of the material that we are working and that is used for these 3 Sustainable Development Goal. So next slide, please. Next. So next. We know there are different development. We have scientific development. We have a technological development. We have economical development. Everybody is having the mobile phone, and using this mobile phone, you know, we can send our data to anywhere in the globe within a few minutes. We are technologically developed. We can send our, you know, mission to the Mars. We can go to the moon because of the development of the science. And science, this is nothing but the outcome of science. It is the technology, and because of the technology, we can able to develop the different kinds of the. We can go to the different kinds of application. There is a globalization, and again we have a what you call the urbanization. There is increase in population, increase in GDP of the country, and most of the basically, you know, for the development, energy is the basic need, and energy, it is obtained maybe before 1950. We use the energy basically biomass, and later we started the coal, using coal. Then there is addition of oil, and there is a addition of again a gas. Today we are using oil, gas, coal, as well as there are again biomass, the nuclear, hydro, solar, but the amount of the energy obtained, it is so most of the energy it is obtained, it is mostly 70% energy it is obtained from the coal, oil and natural gas, and this is the carbonaceous fuel. And we know the basic composition of carbonaceous fuel, that is the carbon. We burn the fuel and there is a emission, we utilize the energy, and there is a CO2 emission, CO2 it is emitted into the atmosphere, and this is considered as a garbage, it is a waste. We know the waste generated in our kitchen. Waste generated from the vegetable waste or a fruit waste, and if we stored it for a longer duration, you know what is going to happen. And this waste CO2, it is a colorless, it is a odorless, we can't able to smell it, we can't able to see it, and it is accumulating into the atmosphere. And this is a killing curve which shows there is a increase in the CO2 in the atmosphere. The current CO2 concentration, it is more than 423 ppm, and it is continuously increasing day by day.
And this is the NOAA laboratory which is continuously monitor the CO2 concentration. And the CO2 emitter, the China, it is the topmost CO2 emitter, and the United States, it is the second CO2 most emitter country, and third one, it is the India. And we know the CO2, it is a global warming gas. There are many global warming gases other than CO2, but CO2, it has a global warming potential one. Other warming gas, other greenhouse gases, it is having a greenhouse global warming potential more than one, but their concentration, it is less, and there is a continuous increase in the CO2 concentration compared to the other greenhouse gases. So people are more bothering about the CO2, and again the lifespan of a CO2 is very large. For a lifespan of CO2, for other greenhouse gases, it was less. So there is a basically, because of the CO2, there is an increase in the global warming, there is an increase in the climatic change, and now it is a 1.2 degrees centigrade above the pre-industrial period. The temperature is increasing. What will happen if there is an increase in the temperature? There will be rise in the sea level, then there will be forest fire, the California forest fire, it is going on. Then again we have a floods, lot of floods. There is a complete load on the NDRF activity. There is again melting of a ice cap. There will be a problem with the life which is on that particular region. There is a storm, and it disturbs basically the life of the different kinds of the people. So what is the solution? Basically, there are okay, so there are the renewable resources like the solar, wind or hydro, one can be used, and it can be combat the climatic change as well as the water crisis. And inspiration of a natural photosynthesis in plant, the photosynthesis, it is emerged as a sustainable and solar energy technology, and that can be used for the various application. So what is the photocatalysis? What is the plant photocatalysis? Basically, photocatalysis occur in a natural plant. It absorbs the CO2 and water, and it gives the basically vegetables, grains and fruits. And survival of a human being, it is depends on the basically plant. If there is no plant, we have whatever the food that we are eating, it is a basically plant-based food, or the animal-based food, again it is graze on the plant. So plant, that is the basic source for the food for the survival of the human being. And looking into the inspiration from the plant, the scientists are developing different kinds of a catalyst, the photocatalyst. And today the photocatalyst, it is called it as the artificial tree. Scientific terms people are using. Basically they are working on the similar principle like that of a plant. So what is photocatalysis for the student? There is a incident of light recently. Professor Dobre, he has shown the photoluminescence. There is a light energy incident on it. There is a emission occur. There is a generation of electron and hole, and the electron and hole react with the surface molecule, maybe oxygen or water. There is a generation of other species, and that other species reacting with the different kind of a pollutant or the CO2, which can be converted into the energy sources. That is the utilization of the species, different kinds of the species, and that is used for the different kinds of the application. So there are large number of the materials that is used as a semiconductor, maybe oxide based semiconductor, metal sulfide based semiconductor, carbon based material, and we are mostly working on the carbon based material. Basically it depends upon, it gives the basically there is no leaching and there is no toxicity associated with it, and basically I'll be working on the graphitic carbon nitride, and we'll discuss some of the systems that we develop related to the graphitic carbon nitride here in this seminar. So graphitic carbon nitride, it is a 2D material, it is a layered structure, and it has a band gap visible region, band gap of 2.7 electron volt, and it has a functionality, different kinds of a functionality, and because of this functionality, it can be easily modified. And it has got advantages as well as a disadvantage. The disadvantage is that the specific area of this Gc3N4 is less, and then the kinetics, it is slow, and there is a rapid recombination of electron and hole which is generated during photocatalytic process, and the high surface inertness, it is not dissolved into many solvent, organic solvent. So, and in order to improve these Gc3N4 properties, maybe lifetime, maybe surface area, we try to modify the Gc3N4 by different process. One of the process that is a grafting, and other process that is by making a composite with the other semiconductor. So this is one of the system that we develop. This graphitic carbon nitride, phenyl, it has been developed, grafted with the graphitic carbon nitride. So phenyl urea it is taken, then urea, it is heated, and to get a phenyl grafted graphitic carbon nitride, there is an enhancement in the basically conjugation. There is enhancement in the conjugation, and because of enhancement in the conjugation, the lifespan of electron and hole, it can be enhanced. And this is the different kinds of the characterization, the XRD in order to understand the crystal pattern, and this shows the amorphous after this grafting. Phenyl grafted Gc3N4, it shows the amorphous structure. There is an increase in the visible light absorption, and this is again the IR and NMR in order to show the different changes that is occur after grafting. This is again the XPS, shows the oxidation state, chemical state of the different element in that particular material, and there is a percentage of carbon nitrogen, it is varying. The carbon nitrogen ratio, it is increased in graphitic carbon nitride, phenyl graphitic carbon nitride compared to the graphitic carbon nitride. Again, this is the same images, and the EDS analysis. EDS analysis, again, it shows the difference in the nitrogen percentage, sulfur, the carbon percentage, that is indicating that there is a grafting of the phenyl in the Gc3N4. And this is a tame picture. It shows the crystalline property, polycrystalline nature, and the amorphous nature of the graphitic carbon nitride. The surface area, there is an increase in the surface area. Gc3N4, it has a hardly 13 milligram per square centimeter meter square per gram surface area, and there is an enhancement in the surface area after grafting, as well as the porous structure, the pores, the size that has been increased. And this is used for the CO2 reduction. This is used for the CO2 reduction. The CO2 it is taken, and there is a addition of this trimethylamine, and with DMF it was exposed with the light, and CO2 it is reduced. The catalyst it was taken, it was reduced, and with time interval the reduced product that has been analyzed using GC and HPLC, and this is the result of the degraded product. The methanol, I think it is not much visible. There is a generation of methanol, there is a generation of formaldehyde, there is a generation of the methane, and there is this is a phenyl grafted Gc3N4. It shows the more enhancement of increase in the generation of the methane as well as methanol as well as the formic acid compared to graphitic carbon nitride. And scientifically one has to justify why there is an increase in the activity of a material after grafting, since there is an increase in the surface area, there is a increase in the lifespan of a material, and this is the proposed structure, how it can be formed. There is a formation of the methane, methanol, and formic acid. And this is used again for the degradation of the pollutant, you know, the dyes or the pharmaceuticals. They are highly persistent in environment for longer duration. And when it is persisting for longer duration, it causes the bad effect, and it is not basically filtered easily by the normal conventional filtration process. And this is one of the dye, rhodamine B. This is basically a pink dye, and this is carcinogenic in nature, and it is highly used for the leather industry, paper pulp industry. And using this dye, we try to degrade this dye, and degradation efficiency is more by the graphitic carbon nitride, phenyl grafted GC3N4 compared to graphitic carbon nitride. And what are the species? You know, photocatalytic process, it involved the different species, the electron, hole, the hydroxyl radical, superoxide ion, and what are the basically species responsible for the degradation of these dyes? That is, that can be done by the, this is a quencher experiment, and this quencher experiment shows the presence of a superoxide ion. It is as a major species for the degradation of the dyes. So again, this is the enhancement in the lifetime. The PL spectra shows there is a enhancement in the lifetime of phenyl grafted GC3N4 compared to pristine GC3N4. And this is the basically mechanism. There is a, when the light is incident, there is a absorption of light, there is a transition of the electron to the conduction band, and there is a, this electron, it will be reacting with the oxide to form a superoxide ion, and that superoxide ion, it degrade the different kinds of the pollutant, maybe rhodamine B, as well as in case of the CO2 generation, CO2 reduction, the electron that is responsible for the CO2 reduction, methanol formation, and the what you call the aldehyde formation, phenol aldehyde formation. In case of a catalytic process, the recyclability, it is a very important. Whatever the catalyst develop, it should be recyclable. It must be reusable. And in order to study the reusability of the material, the reused material, it was the XRD of the XRD it is taken, and it was compared with the original catalyst, and there is no much phase changes, as well as this is a same photograph which will be showing the similar kind of the image compared to the without used catalyst. So this is one of the system. The phenyl, it is grafted with the GC3N4, and there is an enhancement in the lifespan, there is an increase in the surface area, as well as there is a, and that is used for the CO2 reduction as well as for the degradation of the rhodamine B. This is another kind of a system. This is a diaminopyridine. This is again grafted with the GC3N4, and there is a formation of the phenyl, diaminopyridine grafted GC3N4, and again, in order to, we have to characterize it by the various characterization technique, and one has to see the difference. This is a diaminopyridine grafted. It is showing basically the amorphous kind of a structure, and this is the carbon 13 NMR. Again, this carbon 13 NMR, it shows the different kinds of the chemical shift, different kinds of the carbon nature, and it shows the difference in the chemical shift. And this is the, again, XPS in order to understand the oxidation state of the element present. There is an increase in the basically visible absorption. This is the DRS spectra, and the microstructural analysis again shows the TAME, which is showing the amorphous kind of a structure. This lattice fringes, there is a lattice fringes, that is a crystalline structure. It is observed in case of the phenyl grafted GC3, the diphenylamino pyridine grafted GC3N4. So This is used for the hydrogen generation, green hydrogen generation. In order to generate the green hydrogen, the catalyst it was taken. Again, the co-catalyst, the platinum, the hexachloroplatinic acid, it is taken. And it was exposed with the light. It is a visible light, exposed with the visible light. And generated hydrogen, it was analyzed using AGC. And this is a diaminopyridine grafted GC3 and 4. It shows the large amount of generation of a hydrogen compared to the without grafted GC3 and 4. And this is again the recyclability study that we perform. And it shows there is no much significant reduction in the activity of the used catalyst. This is the again XRD and IR of the used catalyst, and unused catalyst which doesn't show the changes in the its structure and morphology. This is again used for the tetracycline degradation. We know the pharmaceutical tetracycline. It is highly used. Again, it is used for a human therapy, for a veterinary application, agricultural application, and this is persist in the environment for longer duration. So we try to degrade this tetracycline antibiotic and using this catalyst, and this is a diaminopyridine catalyst. It shows the more degradation activity compared to the without grafted this graphitic carbon nitride. And this is again used for the degradation of the dyes, the rhodamin B, and this rhodamin B, it is the degradation activity, it is again more for the diaminopyridine grafted GC3 and 4 compared to the original GC3 and 4. And not only the graphitic carbon nitride, there are various dyes that is again tried, the rhodamin B, indigo carbine, the AV7, as well as the malachite green, different kinds of the dyes, and it shows the different kinds of the activity, the anionic dyes, different cationic dyes having different kinds of the properties. And this is again the recyclability study that is performed. And this shows again there is a ESR spectra and PL spectra. It shows there is a increase in the lifespan of the phenyl grafted GC3 and 4 compared to the GC3 and 4. There is an enhancement in the intensity of ESR spectra of a 10 dPa phenyl grafted GC3 and 4, and it shows the higher activity. There is an enhancement in the again the surface area of this material compared to the individual graphitic carbon nitride. This is the another system, and again this is the mechanism, how it can be basically what will the mechanism involved in the degradation process, the absorption of a basically light, and there is a excitation of electron, generation of electron hole pair. There are different reactions that is going to occur, and that species which is responsible for the degradation of the tetracycline or the this is for degradation of the dyes for the different application. So again this is a thiophene carboxylic acid. It was it is grafted on GC3 and 4, and I will not discuss about this characterization. Characterization has to be performed, and this is used basically for the what you called the electro supercapacitor application. This is a cyclic voltammogram, and this is CV. It shows the CV of a this thiophene grafted GC3 and 4. It shows the higher capacitive area compared to the without grafted GC3 and 4, and the capacitive retention, it was up to 83% after 1000 cycles. So that can be used for again for a capacitor application, supercapacitor application. This is again the galvanostatic charge discharge profile, and this shows the TDA grafted graphitic carbon nitride. It is having the longer time for the charging as well as longer time for discharging, and for the different scan rate again it is showing the same kind of a behavior. And again, this is used for the AV7 degradation. And I will discuss, these are the various reactions, and I will discuss, this is the system. This is earlier system, they are with the grafting. The modification of a Gc3N4 using different kinds of the grafting reagent, maybe phenyl or diphenylaminopyridine. And this is for making a composite. Again, by making a composite, one can enhance the lifetime of a, this is generated species, and that generated species that can be used for the different application. We'll discuss only the application, will not discuss this, the characterization part. I will skip out this characterization part. And this is used for the, again, this is used for the capacitor application, the CV of the composite and the Gc3N4. There is an enhancement in the CV area, scanning area, as well as there is an enhancement in the charge discharge profile of this composite. And this is used for, again, degradation of acid violet 7. Acid violet 7, it is a, again, the SO dye, and this is persist in an environment for longer duration, and this is a carcinogenic and mutagenic property. It has a mutagenic property, and it is difficult to degrade. And this is used for, again, this is a recyclability study, and we analyze the basically degraded product using the mass spectra. And mass spectra, the degraded product, it was analyzed by mass, and this is the degradation mechanism that we proposed. It is degrading into dicarbonate naphthol, and then hydroxylation. It gives the phenyl, different phenyl derivatives, and then paraphenylene amine, and at the end it gives the CO2 and water. And in some of the application, we try to use this degraded water, the purified water, for the agricultural application. Here there is no data about that, and this is used for, again, what you called for the antimicrobial application. In presence of this composite, there is a killing of the bacteria, and it is used as a, that is a, this is a bacteria, called it as a E. coli bacteria, and this E. coli bacteria, this is without catalyst, and with respect to time, there is a reduction in the population of this bacteria, and this is the at the end, basically we are using in a basically different kinds of the photocatalytic process. We develop different kinds of the catalyst, and we use it for the degradation of the pollutant, CO2 reduction, hydrogen generation, microbial disinfection, maybe for supercapacitor application. And this catalytic system are found to be stable, and photocatalytic route can be considered to be green sustainable process for energy and detoxification of the organic pollutant, and photocatalyst can play a vital role in the sustainable development. I know most of you are hungry, and most of the people, they went already for the lunch. So thank you for your kind patience, and if you have queries, I can answer the queries. I will be happy to answer the queries. Yeah.
Hello. Sir, thank you very much for your informative talk. I would like to know your perspective. If I take melamine as a source to prepare graphene nitride, on the contrary, if I choose to prepare nitrogen doped mesoporous carbon, means you're already having inbuilt nitrogen in the framework, and mostly giving a graphitic side to the nitrogen moiety. On the other hand, if I start like using aniline, phenol kind of polymers, and prepare nitrogen doped carbon, in which we have 3 to 4 types of nitrogen, including pyrolytic, pyridinic, and graphitic. What is your perspective on catalytic and electronic way?
Yes, definitely one can predict it theoretically. One has to predict basically what are the factors responsible for enhancement of the activity. It is basically the lifetime enhancement, there should be surface area enhancement, and these are the basically two factors, lifetime and surface area, so that the activity can be a better activity. So if we prepared the material, and again you talk about the aniline, aniline as one of the precursor. See, aniline, it is a carcinogenic. Handling it is very difficult, and this is prepared by the firing process. Right, it will be difficult to use it in this heating process. It may have different kinds of the consequences. One has to see what kind of a toxicity that is going to associate it with it, and we have to try. And what kind of a structure, again, Professor this Ssjc, he has done that DFT and other kind of the calculation. One has to go for that kind of a calculation. One has to find out what will be the possibilities theoretically. And if we found that yes, that it can be enhancement of a lifetime of a material, and there is an increase in my structure. There is this is a polymeric graphitic carbon nitride, and I tried to enhance the lifetime by conjugation, by making a enhancement by making a composite, so that there is an enhancement of a lifetime. So one has to see theoretically as well as practically. One has to perform, and one has to do the experimentation. Based on the experimentation only, we can able to come to some conclusion.
Any question? So if you are having some more questions, then you can ask. I think everybody is hungry, so no more questions. So thank you very much, Professor Umre sir. It was wonderful talk, and your presentation speaks volumes about your expertise in this field. Thank you very much, the management and the principal, inviting me as a chairperson for this session for the one-day national conference on recent trends in material science for sustainable development. Everybody is looking at me how fast I can sum it up. So Dr. Umre sir, Professor Umre sir has wonderfully talked about his talk about the polymer materials. He spoke very nicely. He started right from what are the conventional energy materials. After that, he switched over to how and why we need the renewable energy sources. What are the problems with the conventional materials? So it pollutes, high carbon emission that has to be reduced. Also, the environmental pollution that leads with the new kind of materials we develop. So he has given very nicely. He has prepared many materials under his expertise in his lab at VNIT. He spoke about the graphene C3 N4 materials. Further, he has spoke about how the carbon dioxide can be reduced, and how it can be lead to the reduction of the dyes in the materials. He spoke about various materials that leads to the reduction, and actually this field is very complex, and but his work is that is very nice. So I appreciate his wonderful talk about the materials, and thank you very much, sir, for speaking about the subject. Actually, this was not my field, so I could understand less about your work, about this work. So thank you so much, sir. And now I conclude my speak. Thank you.
On the behalf of all the attendees, I sincerely thank you for your insightful and enlightening talk on the modified graphite carbon nitrate for the sustainable futures, multi-dimensional applications. Your depth of the knowledge, clear explanations, and engaging deliver have truly enrich our understanding and these promising materials and its potentially for the sustainability. Once again, thank you, Professor Umre sir, for your valuable contributions. We look forward to more such enlightening sessions in future. On behalf of organizing team and all the participants, I extend my heartfelt gratitude to you for the chairing the sessions, third sessions, Dr. Ahmad sir. With this expertise and the grace, your valuable insight, keen observations, and throughout the guidance, significant enrich the sessions and enhance the quality of discussions. Once again, thank you for your supports and encouragement. Now, all the sessions are over. Next is, I think, lunch. So, all are requested to go for the lunch.
I request one and all, please gather in the hall while we are going to start oral presentation session. Hello. So, we are going to start this oral presentation session, and I hand over the mic to introduce our today's oral presentation session evaluator to Dr. Chaudhary sir. Please, sir.
Hello. Good afternoon, one and all. I am glad to introduce the today's oral presentation evaluators. One evaluator is from Karanja Ghadge College, Dr. Vijay Ragorte sir. Sir is the board of studies in physics member. Other evaluator is the Baban Donge sir from NPW College, Lakni. And the third evaluator is from the Mohta Science College, Nagpur. So I am requesting all the three evaluators for doing their job. Thank you.
So thank you, Chaudhary sir. In this series, the first presenter is Ms. Naina Sunaune. I request her to please